get that link. It should be on my YouTube. So if you don't know what my YouTube channel is, it's youtube.com/@theshyhat. And I'll just leave that down in the chat for everybody to see. We've got all of our previous live streams over there if you want to take a look at any of the previous ones. And let's go ahead and get the link for today's live stream as well. So there you go. All right. So we're going to be continuing on with our digital forensics course, and let's go ahead and start the lesson. All right, everybody, this is HackerFrogs After School. This is Disk Image Forensics Part 1. So we've been doing our digital forensics class, and we've got about three more classes for this particular topic after this, and this is the 5th session. So what are we going to be talking about today? This is the 5th class for digital forensics, and in the last workshop, we learned about the following digital forensics concepts. We learned about Wireshark. So Wireshark is a program which is widely used for network traffic analysis, and we use it to analyze PCAP files. Remember that PCAP files are a bundle of different packets all put together, and they symbolize all the traffic, the internet traffic that's going on across a specific computer network. So we learned a little bit about exporting files from Wireshark, so we could get any file that was captured inside of the PCAP file, and we could download it. And what else did we learn? We learned that we could use a bunch of different filters in the Wireshark program in order to isolate very, very specific types of packets. And this helps us get some information from what exactly is going on the network. And we also learned about searching for strings in packet contents. So even if we don't necessarily know which packet we need to look at first, if we know that we're looking for a packet with a specific word inside of it, we could search for that word and then try to get Wireshark to return only the packets that have that word in them. Okay, so that was what we learned last time. What are we learning this time? So in this workshop, we're going to be going over the following 4 things. We're going to be talking about disk image forensics. So what is this disk image forensics thing? And then we're going to be solving some challenges over at PicoCTF. So we're going to be solving the Sleuth Kit Intro Challenge, the Sleuth Kit Apprentice Challenge, and the Operation Orchid Challenge. So let's go ahead and talk a little bit about what is digital disk forensics. So when we talk about digital disk forensics, we basically mean taking a look at the contents of hard drives or storage drives, really. Digital disk forensics is the examination and analysis of information stored on digital disks, such as hard drives, USB drives, or any other type of storage media. So a lot of people use phones these days. You can also do digital disk forensics on phone contents as well. So disk forensics is often used in cybersecurity incident response to analyze and identify devices that may have been compromised in security incidents. So if for some reason there was a security incident where a person's device was infected with viruses or malware, we could potentially use digital disk forensics to inspect those devices and see what the heck is going on. Okay, so we're going to be using a very specific type of software to do these digital disk forensics exercises. And the software we're going to be using is called the Sleuth Kit. The Sleuth Kit is a popular program used in digital disk forensics, and we can access it from the PicoCTF web shell. So let's go ahead and activate the PicoCTF web shell. So what I want you to do is I want you to log into PicoCTF. So if you haven't already logged into PicoCTF, you can do it from this link over here. And if you don't have an account over at PicoCTF, you can make one and then log in. So after you've logged into PicoCTF, you want to open up your web shell. The web shell is basically a Linux computer that you can use to solve PicoCTF challenges, and I'll show you how to access it. So after you've logged into PicoCTF, you need to click on the practice button over here. It's going to be one of the top buttons when you arrive at the page. You click on the practice button, and then you scroll down a little bit in the page, and you're going to see that there's going to be a web shell button over here on the right-hand side of the interface. So you want to go ahead and click on that button, and that's going to open up the PicoCTF web shell in its small form. So we don't want the small form of the PicoCTF web shell, we want the big version of the web shell. So what we can do is we can go to the PicoCTF web shell and then move our mouse over to the right-hand side, and to the right of the Help button is this button right over here. It's labeled Pop-out Web Shell Terminal. It looks like a box with an arrow pointing out. You want to click on it, and then after that, you're going to see the Web Shell Terminal in its large form. It's going to be in its own separate browser tab. So if you manage to open up the web shell in its big form, let us know in the chat by typing in the web shell is big, just like this. Okay, I see Venting Horse has the web shell big. That's great. And user 3 also has a big web shell. Great. Okay. All right, let's go ahead and start then. So if for some reason your web shell doesn't start up, you can go ahead and do the process over again, and that eventually you'll be able to open it up. Sometimes the web server over at PicoCTF is not very responsive, and sometimes you have to do things maybe 2 or 3 times before you can get it to work. But just keep on trying until it works. Okay, so now that we're at the web shell, we can go ahead and clear off our terminal with the clear command, and then we use ls to take a look at what's inside. It looks like I've got some old files in here, so I'm just going to clear them out with the rm command. So it's rm and then space and the name of the file. We want to keep our PicoCTF web shell nice and tidy, and we don't want any clutter in here, so that we've got a nice and clean interface. Okay, so let's go ahead and go back to the presentation here. So we're talking about the SleuthKit software, and we're going to be learning some basic operations of the SleuthKit in this workshop to learn about digital disk forensics. So let's get acquainted with the SleuthKit with this PicoCTF challenge over here. So this is going to be the SleuthKit intro challenge. I'll leave the link in the chat. Oh, okay, hold on. For some reason it cut off. Use the link that's at the bottom. Use the link that's at the bottom. Okay, so let's go ahead and go over to that link. Okay, so what is this challenge? Let's take a look at the details of the challenge before we start. So over here it says SleuthKit Intro. This is the medium level challenge in the forensics category from the PicoCTF 2022 event. The description of the challenge says, download the disk image and use MMLS on it to find the size of the Linux partition. Connect to the remote checker service to check your answer and get the flag. So it says, note, if you're using the web shell, download and extract the disk image into the temp directory and not your home directory. And then they've got a link to the disk image that we need to access for this challenge. So what I want you to do is I want you to hover over the download disk image link over here, right click, and then select copy link. After you do that, you want to go over to your web shell. And sometimes you're going to see that the web shell is going to disconnect you. It's going to disconnect you if you don't type in the web shell after a few minutes. So you just need to click back into the web shell and hit the enter key to reconnect to the web shell. Okay, so this is what we need to do first. So we need to create a little directory for ourselves inside the temp directory. So the temporary directory is for temporary files. And the reason why this challenge doesn't let us copy the file into our home directory here is because the file is too big. So what we're going to do is we're going to create a directory for us to work inside of. So what I want you to do is I want you to use this command. So mkdir for make directory, then space, and then /tmp/ for something in the temporary directory. And then I want you to type in your username. So for example, my new username is the Shy Hat. Your username is probably something else. You want to type in that username. You don't type in my username, you type in your own username. And then underscore, and then, oh, what are we going to name this? We're going to name this SK for Sleuth Kit and SK1. So your name underscore SK1. And then hit enter. And then you want to enter that directory by doing the cd command. So it's going to be cd space /tmp/ your name underscore SK1. Okay, and after you do that, hit enter. And when you type the pwd command to get the working directory, print working directory, it's going to say /tmp and then your name underscore SK1. So if you type pwd and then you get this result over here, your name underscore SK1, please let us know in the chat by typing in SK1 smiley face. And as usual, if you're having troubles, let us know in the chat and we'll try to answer, we'll try to address your problems as best we can. So the command is going to be mkdir space /tmp/ your name, and you don't necessarily need to type your name like this. It's going to be your name over here, and then SK1 like this. After that, you want to use cd to enter that directory. And then when you type the pwd command, it should give you this output over here, /tmp/ your name underscore SK1. So one more time, if you manage to create that directory and then enter the directory, and when you type pwd, it says this, let us know in the chat by typing in SK1 smiley face. Okay. User 3 has got it done. Any other users, if you're having trouble, let us know because we'll try to help you out. Okay. So let me talk about the next step. So the next step is going to be to download the file. And one more time, we can go back to the challenge page over here, SleuthKit intro, and then we can right-click on the download disk image link, and then select copy link. After that, we're going to go over back to the web shell, and we're going to download the file into our SK1 directory here. So you can type wget space, and then paste in. Oh, yeah, I need to get my link again. Okay, so go back here, select copy link, go back to web shell, paste in this file address here. And you know what? I'm going to copy this into the chat so everybody can do the same command. Okay, so everybody, if you're having trouble getting the command, then this is the command you can just copy and paste. There you go. And then hit enter. That should download the file. It's a pretty big file. And you're going to see the progress bar over here. When it's done, you want to give the ls command to make sure that the disk image is in here. So type ls. You should see disk.img.gz in your file, in your directory here. Okay, and if you see it, type in the chat, I downloaded the big file. Smiley face. Okay, Venting Horse says, I see it. Okay, so you, good to see, good to see. Okay, so this should be disk.img.gz. And the next thing you need to do is you need to unzip the file. So this is a zipped file. And if you want to know what the contents of a particular file are, you can just type in the file command. So file space and then the name of the file. Remember that you can start typing in the name of a file and then hit the tab key on your keyboard to autocomplete the file name. It's a very useful technique for typing in the names of long file names. Okay, so this is gzip compressed data, and it says it was disk.img. So this is a compressed file. We need to uncompress it. We need to unzip it. So the command we're going to do to unzip the file is going to be gunzip. So gunzip, I guess you could say, and then space, and then disk.img.gz, like this. So after you give this command, hit enter. It's going to take a little bit of time, but after it's done, you're going to see this file here. So disk.img.gz becomes disk.img, like this. So this is the command that we give. I'll just paste in the chat just in case anybody needs to use it. Okay, so disk.img. So this is the actual disk image file that we're going to be taking a look at. And if you type in file disk.img, it'll tell you what kind of file this is. So it tells you that this is a DOS MBR boot sector partition 1, and this is what we want because this is a disk image file. And what we're going to do is we're going to use some tools to take a look at what's inside the file. So let's talk a little bit more about this. So the challenge is actually asking us to use the mmls command, and the mmls command is going to display the media management, or MM, of a disk image in the list format. So it's kind of like ls in Linux, but we're doing it on the media management. So it's mmls. And what this is going to do is it's going to tell us where the disk partitions are in a particular image. So the partitions are basically the file system for a device. So an operating system like Linux or Windows is going to have several different disks, and we want to find the Linux disk on this image file. So let's go ahead and do that. So we're going to go back to our web shell, and we're just going to run this command. So it's mmls space and then disk.img. So this is going to tell us where all the disk partitions are. Give the command, and you're going to see that there are 3 different things in the table in this image over here, and we're looking for the Linux one. So this is the Linux partition over here. Remember, if we go back to the challenge, it says download the disk image and use mmls on it to find the size of the Linux partition. So can you tell me, so from this output over here, what is the size of the Linux partition? This is the Linux partition information over here. So can you guess which number is going to be the size of the Linux partition? If you know, type it in the chat. And if you just want to give a guess, that's fine too. So the answer is this number over here, the length of the partition. So length is how much size or how big a partition is, and there's also some very important information here that's talking about the partitions as well. So start over here tells you where the partition starts inside the image. So it starts at 2048 bytes inside of the partition, which means that this is called the offset. It's basically where this partition is inside the image, and it says that it ends at this particular address over here, and then it tells you how large the partition is in length over here. So the length is actually, what is this number? Length seems to be the thing that makes sense. Zos the goat herd, hello, nice to see you on YouTube. Nice to see you. Yeah, so this is going to be, is this 20,000? No, this is 200,000. So this is 200,000, 202,000, wait, 202,752. Okay, so this is the answer that we need to provide to solve the challenge. And this is how we're going to do it. We're going to go over and, yeah, Zos the goat herd. Question, does it need to be changed to human readable units? I think we don't need to change it to human readable units to solve the challenge. And if you're looking for where we can access this challenge, this is the link over here. Okay, so what we need to do is we need to supply the answer in the challenge, and we need to start up our online service to do that. So go back to the challenge page, and then click on the blue Launch Instance button. So click on it, and then wait for a few moments, and then it's going to start up the virtual machine that we need to communicate with. You'll know that it's working when you see this instance time remaining, and you've got some a countdown happening here. So down a little bit, there's going to be the access checker program, and we need to copy this command. So copy the command that starts with NC and ends with this number over here. So highlight it all, and then select copy. Right-click, copy. Then go over to your web shell. In the web shell, you're going to click into the web shell and then paste in the command. So this command is going to be very similar. Your command and my command is going to be similar, except that the number is going to change. So your port number is not going to be the same as my port number. So go ahead and paste in the command and then hit enter. And then it's going to give you the answer. So sorry, it's going to ask you, what is the size of the Linux partition in the given disk image? Length in sectors. So length is the clue here, and you can just go ahead and copy this number. Copy the number, right-click copy, and then paste in the answer here. And then hit enter. And then it'll say great work, and it'll give you a flag. Okay? So if you're wondering what the number you're supposed to put in is, I'll just paste it into the chat. Okay, and this is the flag. So what we need to do is we need to copy the flag, then go over to the PicoCTF page and scroll down to the bottom. At the bottom, there's this flag submission field. Click into the flag submission field, paste in the flag, and then click on submit flag. Okay, and it should say, hooray, you solved this challenge. So if you manage to successfully solve the challenge, type in the chat, I did it. I did it, smiley face. So it is in sectors, answered my own question. Yeah, it turns out it was in sectors. Okay, awesome. Everybody got it done. Okay, let's move on to the next challenge. So over here, back in your web shell, you're going to press Control-C to get out of this. So Control-C is going to quit out of this program. So it's a keyboard shortcut, Control+C. So press those two buttons at the same time, and you should see this this little symbol here. So after that, what we're going to do is we're going to delete this directory. Well, we're going to delete this this image here because we don't need it anymore. So we're just going to delete it. We're going to do rm space disk.img. So go ahead and do that, and then type ls. You should see that nothing appears. Okay? After that, we're going to solve our next challenge. So let's go ahead and talk a little bit more about the commands we're going to be using for the next challenge. So we're going to be going over to this next challenge. It's called SleuthKit Apprentice. And we're going to be learning about this SleuthKit Apprentice challenge and more commands from SleuthKit over here. So let me go ahead and copy this challenge over here. So this is the link I've provided in the chat. Okay, let's go ahead and go there. Okay. All right, so this is the SleuthKit Apprentice Challenge. And let's read up a little bit about this. So it's SleuthKit Apprentice. It's a medium level challenge in the forensics category from the PicoCTF 2022 event. The description says, download this disk image and find the flag. Okay, so we've got this disk image link over here. We need to right click on the link. So download compressed disk image, right click the link, and then select copy link. After we do that, go over to the web shell, and in the web shell, when you type pwd or print working directory, you should be in the temp directory. So once you're in the temp directory, that's the right place. You can type wget space and then right click, paste in. I accidentally got rid of my link. Sorry, we're going to go back to the challenge and then copy the link and then go back to the web shell and then paste in the link. Okay, so this is the command we're going to use. I'll just provide it to everybody in chat. Okay, so hit enter, and that's going to download the file. So the download is not going to go super fast. This should complete in about 20 seconds. So 20 seconds can seem like a long time. But you should see the loading bar over here, the progress bar, I guess, and it'll slowly fill up until it hits 100%. Okay, and then after that's done, if you type ls, you should see that the disk.flag.img.gz file is here. If you see it, let us know in the chat. Type in I see it with a smiley face. Okay, great. Thank you for using the same smiley face. Okay, so this is what we do. We need to unzip this file. So we're going to unzip it the same way we did it last time. So we're just going to give the gunzip command. So gunzip space and then disk and then hit tab to autocomplete the file name. So this is the easier way to do it. After that, hit enter. And then when it's done, type ls, and you should see the file has changed names. So it goes from disk.flag.img.gz to disk.flag.img. So this is what we want. So if we run the file command on disk.flag.img, we should see that this is a DOS MBR boot sector, partition 1. So it's got several different partitions over here. So there are a few different partitions in the image file, and this is what we want. Okay, so the next thing we're going to do is we're going to run the same command we did in the last exercise. And in the last exercise, we ran the command mmls space disk dot, well, the name of the file. So in this case, it's disk.flag.img. So go ahead and give this command. you're going to see that there are a few different partitions in here. So there's going to be primary table, unallocated, and then Linux, and then another Linux, and then a third Linux over here. So if you manage to successfully give this command, and you see this kind of output over here, let us know by typing in, I see the parts, smiley face. So I just want to make sure that everybody's on the same page. And as usual, if you're having troubles, let us know what part you're stuck at, and we'll try to help you get back on track. Okay, and we're going to learn about a new command now, okay? So a new command we're going to be using from the Sleuth kit, and this is going to be the fsstat command. So fsstat stands for file system fs statistics stat. And the fsstat command is used to display statistics or stats associated with the file system, or fs. So when we run this command, it's going to give us a bunch of information about the partitions. But we also need to supply the byte offset of the disk partition with this -o over here and the name of the disk image. So this is what we're going to do to run the fsstat command. Let's go back over to the web shell. So we need to give this number over here for start for each one of these partitions. For example, 2048, or 206848, or 360448. And this is how we're going to run the command. So fsstat space, and then -o for the offset, and we're going to supply the number over here. So we're going to start with the 2048, and then space, and then the name of the file. So the name of the file is disk.flag.img. So we can just copy and paste this if we want. When we give this command, it's going to give us a bunch of information about this disk, about this partition rather. So we don't need to pay too much attention to this information, but we are going to pay attention to the stuff at the top. So at the top, it gives you file system information, and then it tells you what kind of file system it's using. In this case, it's using ext4. This is a type of Linux, a Linux file system. So it gives you the volume ID number and a bunch of information about this file system. So the only thing we really need to know is that this is using an ext4 file system, because we're going to be using this in some further commands. So let's go back down, and then let's clear. Remember, you can do up and down in your web shell to get your previous commands. So if we wanted to run this mmls command again, we can just go up and down in the history and then get that again. So what we want to do is we want to run the fsstat command again, just to make sure that these are all using the same file system, the ext4 file system. So we're going to give the fsstat command again, but this time we're going to run it with this number. So 206848. And this is going to be checking a different partition. So we just checked this one. We just checked this first one over here. We're going to check this one next. Okay, so when we give this command, it says cannot determine file system type. So we can ignore this partition here because it doesn't seem like we can read it. So we're going to read the last one instead. And the last one is number 360448. And let's go ahead and change out that number. So the number is 4360448. And when we get the information about that, let's scroll up back to the top. And we get this information here. So this is also an ext4 file system type. And while this is all the information we really need to know about this right now. Okay, so let's go back down to the bottom. We can clear the screen. And let's take a look at the next command we're going to be given. So we did the fstat command to get information. And we're going to get the fls, we're going to do the fls command next. So the file system ls command, this is going to get the contents of the partition. So this command is used to list out files and directory within a specified file system. And we need information that we got previously to run this. And we're going to get the we're going to give the ext4 file system with the -f here, and we're going to give the offset with the number here, and then finally we're going to specify which image that we're going to be running it on, like this -r. So let's go ahead and do some of this. Okay, go back to the web shell. So we're going to do mmls again just to get these numbers, because we need these numbers to run the commands. So we're going to run fls, then space, and then -o for the offset. We're going to check this one over here, 2048, and then space. We're going to give the file system, so -f, it's going to be ext4, space, and we're going to give the name of the image file. So -r disk.flag.img. Okay, so this is the command we're going to be using. Okay, I'll just paste it into the chat. We've got ads running on Twitch right now, so we're just going to take a little break, about a minute or so, and we're going to run an ad on YouTube as well. And in the meantime, while we're taking our break, we're going to watch some birds. So these are my favorite birds right here. And I want to show them to you while we take our little break. And they're taking a little break too. So just take we're going to take about a minute break while the ads run, and we'll be back in about 50 seconds. So we got another half minute of ads going on right now, so we're just going to be holding tight for another 20 seconds. If you have any questions about what we're doing, let us know in the chat, because it might seem a little bit confusing if you're coming into this halfway. But we're trying to take a look at some information from this disk image over here that we downloaded. Okay, let's go ahead and put the birds away, and let's continue on with the lesson. Okay, so when we give this command over here, it's going to give us some the stuff, or the contents of the file system. So we see here that there's not very much here, and this is not what we're looking for. So we're going to ignore this particular partition. So we know that there was one more partition that we needed to look at, and it's this one over here. So the offset is going to be 360448. So we're going to give the same command, except we're going to replace the number for the offset. So we're just going to copy this. We're going to bring up the old command by hitting up in our keyboard, and then we're going to replace the number. So we're just going to get rid of the previous number. We're going to paste in the new number, and we're going to give this command again. And I'll just paste in this command for this command. And okay, so when we give this command, we're going to see a lot of stuff over here. So we've got a bunch of these orphan files. We've got a bunch of different files and directories, but most importantly, down near the end of the file. So this is the end of the file. It's just a bunch of these orphan files. We scroll up a little bit until here, we're going to see some interesting files. So they've got, we're looking for the flag file over here. So we got flag.txt. This is the name of the file. And we've got flag.uni.txt. So an interesting thing here is that it's going to tell you what the node number of these files are. So when we read these files, we're going to need to tell the command the node number. And the node number for this file, flag.txt, is 208.2082. And let's go ahead and read this file. So this is flag.txt. So, okay, I'm going to tell you ahead of time, this file has been deleted. So you can tell that something is deleted because it's going to say real alloc or realloc for reallocated. It basically means that the when the file was here, whichever space that this file occupied has been reallocated because it's been deleted already. But let's try reading this file, flag.txt, and I'll show you what it looks like. Okay, so we're going to go down. Remember, the node number that we're looking at is going to be 2082. So we're just going to remember this number. I'll just paste the number into chat. Okay, we're going to go down, and we're going to use the last command we're going to be learning for SleuthKit today. And that command is the icat command. So the inode cat command, this is used to read specific files in a disk partition according to its inode number. So we need the inode number to read this. And to use the command, we need to supply the format of the disk partition, which is the -f, the offset of the disk partition, which this is the -o, and finally the name of the disk image and the inode number, which would be disk.flag.img, and then some number. So let's go ahead and do that. So back at the web shell, just going to clear this off. We're going to do the icat command. Let's see, we need offset, and the offset was 360448. We need to give the file format ext4. We need to give the name of the image file, disk.flag.img, and the name of the file, the inode number is 2082. So let me try giving the command just to make sure that this is the right thing, and then I'll copy it into chat. Okay. So this is the command here. All right, so when we give the command, we actually don't get any useful output here because this file's been deleted. So the command we did to get the file list was this, and this flag over here was reallocated, which means that the file doesn't exist anymore. But there's another file over here that we could potentially read, and it looks a lot like a flag, but slightly different. So it's going to be node 2371. Okay, so let me copy that number. And let's go back down. Let's clear the screen, and let's give the same command. This is the icat command, only we're going to be using the other number. So the number is 2371, and let me paste this into chat. Okay, so when we give this command, this is the actual flag that we're supposed to be looking at. And the flag is PicoCTF byte surfer something something. Go ahead and copy the contents of the flag. So highlight it and then right-click copy. Then go over to your PicoCTF challenge, scroll down, and in the flag submission field, paste in the flag and click on Submit Flag. And that finishes the challenge. Okay, so if you managed to finish that challenge, please type in the chat sleuthkit done, smiley face. Okay, great, great. See, some people are finishing the challenge. That's great. Okay, so the other thing that we want to, so the question is why was the file called flag.uni.txt? So here's the thing. Let's go ahead and go back to the file system ls command over here, and we're going to see that in these files here, there's the flag.uni.txt, there's the flag.txt, but there's also a history file over here. So in Linux, history files give you a list of commands that were run on the file system as history. So what we're going to do is we're going to read this file to see what commands were run on the system to delete the flag and to create this new flag over here. So this node is going to be 2363. So we're just going to run the icat command with this node over here. So let's do that. Okay, so it's the same icat command that we did before, only we're going to change out the number. So the number in this case is going to be 2363. And when we give this command, when we read this file, these are all the Linux commands that were run on the file system. And so they're basically editing files, they're making a directory, they move into the directory, they create a flag.txt file, and then they do a conversion command to create a new file called flag.uni.txt. And then they copy the contents of that into they copy the contents of the flag.txt file into flag.uni.txt, and then they use the shred command. So the shred command basically makes it so that you delete a file, but you also scramble up the bytes of the file so that if you use some sort of program like the Sleuth kit to try to take a look at the contents of the file, the file contents are going to be shredded up. So that's what happened. Okay, let's see if we can do one more challenge before we finish up for today, okay? So we're going to do the last challenge. Where is the last challenge? Over here. It's going to be called Operation Orchid. Okay, and let's go ahead and start the challenge. I'll leave the challenge link in the chat. Okay, so this is going to be just like the previous challenges. We're going to unzip a file, we're going to download a file, and go ahead and go over to the link, right click, and select copy link. After you do that, go over to your web shell and delete the previous challenge file over here. So it's going to be rm-disk.flag.img. After you do that, we can download the new file. So the file, we're just going to do wget space, paste in the file address, hit enter, and that's going to download the file. So let me get the command for that, and I'll paste that in the chat. Okay, so users Venting Horse and user 3, are you in a big rush today? Or do you need to get to another? Need to do something else in the next 15 minutes or so? Because if you're busy, then we can finish up the class early. We can finish up the class now. But if you've got a little bit of time, okay, you're good. Then we can do this last challenge. Great. Okay. So after you've downloaded the file here, we can unzip it. So if you remember from last time, it's just going to be gunzip space disk.flag.image.gz. So just give that command, and I'll leave the command in the chat. Okay. All right. So after you do that, you should see disk.flag.img. So if you see this file in your directory, then you're ready to go. Let us know that you're ready to go by typing in ready to go in the chat. So just like the previous challenge, we're going to be using the same commands that we did in the previous challenge. So that's going to be, let's see, mmlms space, and then the name of the image is going to be disk.flag.img. Then we're going to see that there are three Linux partitions here. And just to save a little bit of time, I'm just going to tell you that the partition that we want to take a look at is the last one here. So this is the one with the offset 411648. So what we're going to do is we're just going to get our information about that. So it's fs-stat space -o 411648 space disk.flag.img, and I'll just paste this into chat in case you need to use it. Okay, so give the command, and just like the previous challenge, we also see that this is an ext4 partition here, so we're going to be using this in the next commands. So the next command we use is going to be fls. So fls, and then who just followed on Twitch? Thank you very much, Moby. Mob or Moby? Let us know. Welcome to HackerFrogs. So it's fls-f, and then it's going to be ext4. And then we're going to give the offset, and I think the offset was 411648, and then we give the name of the file, so disk.flag.img. So these are the contents here. Let me copy the command for everybody. There you go. Okay. So we see here that there's a root directory here. So we want to see the contents of the root directory, because when we do these kind of challenges, there's usually all sorts of fun goodies like flags and stuff over in the root directory. We see that the node number, oh, disconnected me. Okay. So if it disconnects us, that means that all of our information is going to be wiped out. So just a second, let me go ahead and re-download all that stuff. Let's see if my directory is probably not there anymore. So cd tmp the shy hat sk1, nope, doesn't exist. Okay, I'll just make the directory. So just a second, everybody, I just need to re-download the file and I need to redo the thing. Okay. Whoops. We made the directory, and then we go into... Oh, I misspelled Shyhat. Like this. Okay, let me download the thing. Okay, back here. Copy the link. wget. So just a second. Sometimes you'll get disconnected randomly from the web shell. It's a bit annoying, but it is what it is. Okay, so that's done. Let me unzip the thing. Okay, and what were we going to do? We're going to do the file system ls, right? Let me go ahead and copy that command. Whoops. Okay, let me just type in the command then. So fls-fext4-o 411648 dis.flag.img. Okay. All right, so this the root directory, we want to take a look at this. So we're just going to do let's see, I think it was the icat command. Hold on, let me take a look at my notes. So everybody, if you want to get all of the information for how to solve the challenges that we did today, it's going to be over here at the GitHub page. So you can take a look over here. This is, what is it? This is the Operation Orchid challenge. Let's see. Disk partition FLS. We want to look at the root directory and note its node number. It is going to be 472. So we're going to do FLS to take a look at the root directory with this command over here. And let's go ahead and do that over at the web shell. Okay, we're going to paste in the command. So the order of the command is a little bit different over here, but the order doesn't really matter that much as long as we have all the information in there. So this is the command here. Let me just give it to everybody. Okay, so what do we have inside the directory? So there's the history file again. There is the deleted flag file over here. So remember, when we see this this message over here, realloc, that means that the file's been deleted. And we also have the flag.txt.enc flag. This is the flag file, but it's been encoded. And we need to decode this flag before we can get the contents of it. So what we're going to do is we're going to read what happened to this flag inside the history file. So the history file has this node number here. So we're going to do the icat command. So icat space, let's see, so format is ext4, and the file is disk.flag.img, and then the node number is 1875. Okay, invalid magic. Oh, I forgot to lift the offset. We need to give the -o. So -o 411648. Okay, and let me paste this command in for everybody. Cypher Enigma says, "Evening. Hello, Cypher Enigma. Nice to see you here." And yeah, we're just wrapping up our little class in just a little bit. We're learning about how to take a look at disk forensics using the SleuthKit software. Okay, so this was the history file, and we find out what happened with the flag inside these this history file here. So we made a flag, we edited the flag, and then we used the OpenSSL program over here. So this is basically a program that we can use for encryption and decryption, and we encrypted the flag using this passphrase over here, unbreakable password 12345667. So what we're going to do is we're going to get our own flag, our own encrypted flag over here, and then we're going to decrypt that flag using the OpenSSL command again. So the first thing we need to do is we need to get our own flag.txt.enc file, and we see that it's over here at this node. So the node is 1782. So we're just going to use the icat command again. So it's going to be 1782. And if you take a look at the contents of the file, we can't read this because it's been encrypted. But that's fine. What we're going to do is we're going to give the same command, but we're going to redirect it into flag.txt.enc. So we're just going to make a copy of this file here, and let me get the command for you so you can do it yourself. There you go. So when you give this command, you should see a file in your directory when you do the ls command that's called flag.txt.enc. And if you read it, it's got the same contents as it did when we used the icat command. So what are we going to do now? We're going to decode this flag, and we can do that with the OpenSSL command one more time. So the command is kind of long. I'm just going to copy it from my notes over here, and I'm going to give it to everybody in chat. So the command is going to be, let's go back to the web shell, this over here. So it's OpenSSL AES256 -D for decode and -salt for have a salt. The in file that we're going to give to OpenSSL is going to be flag.txt.enc, and the file that we want to output is going to be called flag.txt. We also give the salt that was used to create the file. It's going to be unbreakable password 1234567. So when we give this command, it's going to give us a warning over here, but that's okay. The important part is that there's now a flag.txt file in our directory, and we can read it using the cat command. So the flag is this. So PicoCTF haunting past. So we can highlight the contents of the flag. Remember that it starts with the P and it ends with the ending squiggly bracket over here. So copy that flag, go back to the challenge, and then paste in the flag in the submission field here. Then click on Submit Flag, and then you're done. Okay, everybody, if you managed to finish that challenge, please type in the chat, orchid, smiley face, maybe 2 smiley faces. And as usual, if you had any problems, okay, some people have finished the challenge. Great. If you're having any troubles with the challenge, let us know, and we'll try to help you out and get you unstuck. Okay, so let's go ahead and finish out the lesson, and then we can move on to the next part of the stream. Okay, so we did Operation Orchid, and let's review the digital forensics concept we learned in this workshop. So SleuthKit, the SleuthKit software. The SleuthKit is a popular program used in digital disk forensics and includes several useful commands for interacting with disk images, including the MMLS command, which displays the media management of the disk image in a list format. So it basically lets you know where all the partitions are. We use the fstat command, which is used to display statistics associated with the file system. And what's next? So in the next HackerFrogs After School Digital Forensics Workshop, we're going to use a different program to look at disk images in a more intuitive way. So we're going to use a program that was built on top of the SleuthKit, and it's called Autopsy, and it's a very popular program for disk image forensics. Okay, so this is the end of the HackerFrogs After School portion of the stream. Let me go ahead and finish out the call with the students in Zoom, and we're going to come back and we're going to change topics on the live stream after that. So we're going to go over to the Be Right Back screen on YouTube and Twitch. We'll be back in a few minutes after I finish with the students on Zoom. So hang on. All right, everybody, we're back. So let me go ahead and turn down that music. It's a bit loud. Okay, so what are we going to be doing next? We're going to be talking about some programming stuff next. We're going to be talking about the C programming language, and we're going to be using, let's see, we're going to be using PicoCTF to take a look. So this is the link for the module we're going to be using today over at PicoCTF to learn about C. We're learning C because there are a bunch of binary hacking challenges and reverse engineering challenges that are written using the C, that are used programs written in the C language. So we want to familiarize ourselves with C so that we can solve those challenges. So let's go ahead and talk a little bit about this. In the meantime, let me change out the music and let's put on some chill cyberpunk music. Here we go. Okay, so as usual, if you have any problems with the volume for this particular music, let us know. We'll adjust the volume to suit your needs. We got ads running on Twitch, so we'll also run them on YouTube. And we'll also put on some birds, because we love our birds. And we'll be back in about a minute or so, okay? We're just going to take a little water break for about a minute, and we'll be back. Okay, we got another 20 seconds of ads. These are some hungry birds. Okay, let's put the birds away and let's start our little lesson on C structures. So this isn't. So as far as C is concerned, I'm not an expert by any means, and I'm here to learn about stuff as much as you all are. But let's see if we can learn C. This is a lesson on structures, and structures are something that I don't use very much in my day-to-day programming life. Mathy Dev says, "Hello, Frog Hacker." Hello, Mathy Dev. It's nice to see you here. And we're just about to start a little lesson on C.
Hack the planet! Hack the planet!
You can join in along with us as well, as long as you have an account over at PicoCTF.com. So the course is free, so you don't need to worry about paying for anything. And yeah, if you want to join in along with us interactively, you can do that over there. But let's go ahead and start the lesson. So the introduction. So this is the lesson on structures. Matthew Dev says trying to fix their PC. Okay. May I ask what's wrong with the PC, or is that a secret? If it's a secret, then let us know it's a secret. We won't ask about it anymore. So throughout this course, we have defined many different variable types, like the integer and the character types. These are known as basic types and are built into C. We've also defined data types like arrays and pointers, which are known as derived types. Derived types tend to be a collection of basic types to create a new, more powerful data type. We will now explore another derived type, which is the structure. In C, structures allow programmers to create user-defined data types. Structures like arrays allow you to collect many data types into one single data type. But unlike arrays, structures can be a collection of multiple data types. Matthew Dev says, I installed a new SSD, but when I start my PC, it gets stuck in the motherboard load screen and I can't load the, and I can't join the BIOS. That seems like a, that certainly seems like a problem. I would suggest disconnecting the new SSD and make sure that your PC can start without the SSD. And then, yeah, we need to make sure that the SSD is connected properly. And then we need to see if we can access BIOS. So if we can access BIOS, then we can try to see if we could change the boot order. It might be that that your computer is trying to boot from some non-hard drive device, which would be a bad thing. Okay, so in C, structures allow programs to create user-defined data types. And let's see, unlike arrays, structures can be a collection of multiple data types. So, for example, in this structure over here, we've got characters, we've got integers, doubles, etc., etc. So the above image represents a structure and the different types of variables contained within it. This type of packaging is beneficial because it helps build and pass around logically related data into a single user-defined data type. Oh, Sigma, hello! Nice to see you here. Matthew Dev says, I already removed the CMOS battery. It started when I removed the SSD. Yeah, so if it starts when you remove the SSD, then we need to figure out what the problem is with the SSD that's causing it to make your PC not boot up. Okay, so the instructions over here. So take a look and run the code inside the workspace. Notice in this script.c file all of the variables that are defined. Think about how you use structures to organize the data. So what do we have in here? So in the code window, we've got our main function. We've got a bunch of different variables. So we've got first name, last name, age, profession, and then we can print all these things out. What they're trying to make us think about is how we could turn this into a structure. And inside the structure, we would have all of these different variables in a very convenient place. Okay, let's go ahead and move on to the next section. And Sigma, hey, nice to see you here. Let's give you a nyancat. Okay, so we're defining the structures here. So to help us understand how to include structures, also called structs in our code, let's take a look at how to define them. So we define the structures like this. So struct is the name of the type, and then the name of the structure is going to be capitalized. So in this case, it's bottle. We've got a bunch of different variables in here that we can include in the structure. And the last thing we do is we give a little semicolon to complete the instruction. Honor to be nyanned. Yeah, it's well, you know what? If you're on the internet, you're going to see that nyan cat. So in the image above, the struct keyword initiates the structure type definition. Bottle is the name of the new structure type. And an interesting thing is that when you're creating structures, you should capitalize the first letter of the name. So a set of curly braces to enclose the struct member variables. Inside the braces, the member variables are packaged together. Member variables can be any of the basic types, like integers and characters, etc. They can also be derived types like arrays, pointers, or even other structures. It's important to note that the member variables should only be declared non-initialized. So we will learn about this later. Attempting to give the member variables values will lead to an error. Okay. So in the instructions, we need to define our own structure. So within the main function, we need to declare a structure called person. We need to keep the body of the structure empty. Okay, so this is what we're going to do. Hold on. I've got the stuff that I had here previously. We shouldn't do that. Okay, so we need to create a structure. So it's struct, and then the name of the structure, it's going to be person. And then we need to give some squiggly brackets. So after the squiggly brackets, we need to put a semicolon. And inside here it says don't put anything in here. Keep the body of the structure empty. That's fine. Let's go ahead and run this. Okay, so that's fine. So this the second instruction is inside the person structure, define a string member variable. String member variable. Okay, the first name, and it's going to be a length of 25. So 25 is going to be the expected length of the character array. And we're going to do that like this. So it's going to be character first name, and it's going to be 25 characters in length. Okay? And it also says define an integer member variable age. So that's going to be on the next line. So remember, we need to terminate all of our instructions with a semicolon. This is something I really had to get used to after using Python for a long time. Okay, so the next one is going to be integer age, and that's all we need to do here. So we're just going to run this. Okay, that's fine. All right, let's move on. So initializing structures. Now that we know how to define structures, let's take a look at how we can use them in our code. So what do we have here? We've got a struct. It's called bottle. It's got a name. It's got a max capacity, and it's got a current capacity. So these are the three different attributes it has. So it's got a name, it's got a max capacity, current capacity. When we create an actual bottle structure, we use the struct keyword. We use the name of the struct we're trying to create, which is bottle, which was defined up here. And we have to give it its own name, and this is going to be bottle1. So we initialize this with the information in order here. So the first thing is going to be the name, the second thing is going to be the max capacity, and the third thing is going to be the current capacity. So that's going to be super bottle and 24 and 0 respectively. So after that, we have to give out the semicolon to complete the instruction. So in the above example, this defines the struct bottle from the last exercise. The last line of the code then initializes a struct using an ordered notation. The struct keyword, once again, the user-defined struct type, which is bottle, the name of the structure variable, which is bottle1, the member variable value assignments within a set of curly braces. Okay? And then the order of values assigned to the member variables match the order in which the variables were defined in the structure. If you wish to be more specific with your initialization and not worry about putting elements in the right order, you can do it using an unordered notation. Okay, so you can also create, or I guess the word is instantiate, a struct like this as well. Once initialized, structures allow you to work with complex data types in a more cohesive and efficient manner. Okay, so what do we have in these instructions? So before you initialize your first structure, expand the person struct. Inside the person definition and right after the first name definition, add a last name string member variable with a length of 40. Okay, so we're just going to add on to our struct for person that we did in the last section. So let's see. Right after the first name definition, hold on. For some reason, it saved all of my input over here. So first name is this. We're going to write our code below in here. So we're going to add our last name membership definition. So character last name. This is going to be 40 characters long. And we're going to terminate this with a semicolon. Okay, I think this is all we need to do. Okay, so the second thing we need to do is we need to instantiate a person using the person struct. So inside the main function and using the ordered notation, initialize the person structure person1 with the data below. Be sure to place the data in the same order as the member variable definitions. So we're going to create a person struct now. So it's going to be struct person person 1. And then we need to use the equal sign over here. Vibex. Hello, nice to see you here. You follow me on YouTube. Awesome. Why don't we give you a Hack the Planet? Welcome to the stream. Oh, I misspelled the word redeem. Okay, let's do one more Hack the Planet.
Hack the planet! Hack the planet! Shut up again!
Vibex asks, do you remember me? Can you tell me which video you commented on? Maybe I'll remember your comment. It's hard for me to remember all the usernames. But this is your first time in the live stream, right? But yeah, we're just going to, let's see, create this structure over here, struct person 1. We need to put in our curly braces and the semicolon here. Vimex says, I was in a couple of your YouTube streams, first on the Twitch. I remember I asked about beginner stuff. I want to go to a CTF in Las Vegas. Oh, okay. Are you still asking about beginner level stuff? I got in trouble for hacking my school. Don't hack your school, everybody. If anybody's listening and is thinking about hacking their school, don't do it. But yeah, if you need some advice about beginner level content, let us know, and we'll try to point you in the right direction, because that's what we do here. Almost got expelled. Don't get yourself in trouble. Hack legally. Don't hack illegally. Okay. Okay. So what do we need to do? So we're creating this struct person 1. We need to define all of our definitions over here. So we need the first name, the last name, and the age. So the first name is going to be Ada, and then the last name is going to be Lovelace, and the age is going to be 28. So this is in the order that we define them over here. So first name, last name, age, just like this, and I think this should be all we need to do. Okay, great. Samurai Dante says, "What's up?" And let's see. C just seems tedious, not gonna lie. Well, I mean, it's a bit more verbose than Python is, but you know what? This is old school. This is old school coding, so it's gonna feel a bit tedious, yeah. Vimex says, I know all the beginner stuff, I just need to start learning Python and C++. I already know a bit of Python. Oh, that's great, that's great. But yeah, you said you were trying to get to CTF. Have you done CTFs before? Let us know what kind of experience you've had already, and we'll try to point you in the right direction. Okay, so the next thing we do is instantiate another person using this person struct inside the main function using the order notation. Initialize with the person structure person 2 with the data below. Okay, so this is basically going to be the same thing, only we're going to be creating a different person structure. So this is going to be struct person 2. We're going to give it inside the curly braces and the terminate with the semicolon. It's going to be first name Marie, last name Curie, and the age is going to be 44. Okay. Let's see. Vimex says, I haven't done any hands-on ethical hacking yet. Although I've worked a little bit with Hack This Site, HTML was interesting to learn about. Richard Colby says, C can be a bit tedious, but he can really get some low-level control over the system. My former professor used to say, if you're not crashing your computer a couple times, you're not trying hard enough. Let's see. There's when you say Trojan, are you talking about viruses or are you talking about something else? But yeah, I don't know if we should be seeing those ads on Twitch or not. Anyways, let's go ahead and see if we instantiated this one okay. But Richard Colby, yeah, I think if you really want to get very low into the machine code or close to the machine code, you definitely want to be using C. And another thing that is interesting about C is that if you understand C, you understand Linux better, because Linux was created using the C language. So there's another little fun tidbit. Okay, let's move on to the next section. Vimex says, low-key, let's see, is that a good age to know most basics, or am I behind with my learning? I got into cybersecurity stuff when I was really old, so if you're the age you say you are, then you are ahead of the curve. You know what? Here's what I would do, right? There's PicoCTF over here, and PicoCTF is a site that's geared towards teaching cybersecurity to people in your age range, right? So middle school students and high school students. I would go over here and start solving some of the challenges over here. And you know what? I can give you a playlist of PicoCTF challenges. It's a really good place to learn about beginner cybersecurity. Let me get my playlist from YouTube. Over here. Okay. Get the playlist link. Go ahead and take a look at that link. If you think that the challenges are really easy, what I want you to do is I want you to try doing the challenges yourself without looking at the walkthrough video. So inside of each one of these videos, there's going to be a link to the challenge, and you can go ahead and go to the challenge and try to solve it yourself before watching the walkthrough video. Maybe you can solve it without consulting the video. That's fine. What I want you to try to do is I want you to try to solve all of these challenges over here. There's like 96 different challenges here. Give it a try. Give it a try. Let's see. The Bajaro88 says, I learned some Java and C# a few years ago, but I need to pick up some C and C++. I'll do it today after the stream. After you, are you talking about my stream or your stream? Do you stream Vibex? Let us know. Okay, let's go back. So why use structures? So we're going to take a step back and discuss why we would want to use structures. Look at an example of a program that uses the bottle data without structures. So we've got these variables for our bottles. So medium bottle, large bottle. We've got different max capacities, different current capacities. And if you create a lot of these different structures or a lot of these different objects, it's going to take a lot of lines in the code. Vibex says, my stream Minecraft and other games. No self-promo intended. You know what? If you want to watch some Minecraft, let's give you a shout out on Twitch. So let's see, shout out Vibe XVT. There you go. So if you're here and you like watching Minecraft content, then you can go ahead and give Vibex a follow. All right, let's move on. So notice that we need to keep track of 6 variables while working with this bottle data. As we increase the number of bottles, the number of variables would increase by 3 per bottle. This approach would get extremely unmaintainable. So in a small number of situations, we could possibly use arrays, but that's only when the data is the same type. So this isn't useful all the time. So we're going to be using structs to make creating a bunch of different objects, or a bunch of different I guess in Python these would be classes. So classes of objects in specific classes. But in C, we use these structs over here to group all this information. Okay, so using this username account more. Evening says Glymex. Glymex, hello, nice to see you here. Okay, so let's go ahead and take a look. So if we decide to use a structure for the bottles instead, we get much cleaner code. So we define the structure here, and then we create the structure objects in here. So we got bottle 1 and bottle 2, and this is all done in much less code, especially if we decide to create a lot more of these bottles. Vibex says, sorry, personal question. I was just wondering if you are cybersecurity professional. I did work as a cybersecurity professional previously. I was doing web app security testing. I did that for about half a year, and then I decided I wanted to do teaching more. So I've decided to do cybersecurity education here on Twitch and on YouTube. So using a struct to encapsulate all the members that represent the bottle, we can, number one, reduce the complexity of representing a set of data with one variable. We can package different but logically similar data together, and we can better represent real-world things into data types. Being able to represent data using structures is extremely beneficial as you continue working on more complex real-world problems. Okay, so what do we got? We got some instructions. Somebody's been working with a group of variables that represent coffee table data. Use structs to organize this data. So in the main function here, we're going to create a table structure. We're going to define the variables inside the structure: length, width, height, and color. Okay, so let's go ahead and do that. Hold on, I need to reset this workspace. Okay, so we're going to create a structure. So struct table. And struct table, we need to create some stuff between our curly brackets. And what are we going to do? So we're going to... So there's going to be int length. There's going to be int width. There's going to be int height, and there's going to be character color with a size of 20. Okay, I think this is all we need to do. Let's go ahead and run this. Okay, great. Okay, so the second step is to now initialize the data using the define structure. So inside the main function, we're going to be initializing the table1 structure using the table struct and the first set of the table data, okay? And then we're going to initialize table 2 using the table struct and the second set of table data. So we've got our table data here for the first table and the second table, and let's go ahead and create these table structures over here. So it's going to be struct table 1, and we're going to do curly braces and a semicolon. We're going to do the same thing for table 2. So let's go ahead and fill in the data for table 1 first. So it's going to be 24, and then 24, and then 20, and then dark brown. So these correspond with the length, width, and height, and then the last one is going to be the color, which is a string. So we can also make this a little bit prettier by adding in some spaces. Wait. Yeah, like this. And we do the same thing for the second table over here with these numbers. So 42, 18, 32, and matte black. Okay. So it's 42, 18, 32, and a string, matte black. Okay, so this should be all we need to do. Let's run this. Oh, looks like I made a mistake somewhere. Okay. This needs to be equals. So when we do the instantiation, we need to give the definition by adding the equal sign over here. Okay, let's try that again. Okay, now it works. Great. All right, let's move on to the next step. So structured dot notation. So if you're familiar with Python objects or Python classes, then this is going to seem a little bit familiar. So now that we've leveraged the power of structures to package variables together, we can discuss how we can access each member variable individually using dot notation. So dot notation is a C operator that allows you to access and modify a member variable of a structure. Have I seen the, let's see, Vibex asks, have I seen the show Mr. Robot? Yeah, Mr. Robot's a pretty cool show. It's got a lot of hacker themes, and it talks about some of the stuff that was in the hacker culture prior to the year 2020. I think the show came out in like 2017 or something, 2018. Yeah, I love that. I love that show too. It's a great show. Okay, so dot notation is a C operator that allows you to access and modify a member value of a structure. So, for example, if we got the bottle structure over here, we can access the definitions by using the dot notation. So, for example, my bottle dot current capacity, or my bottle dot max capacity, or my bottle dot name to refer to the structure. The oh gosh, what are they called? Definitions inside those objects, those structures. Okay, so in the example above, the bottle structure is defined and initialized with the variable myBottle. The member variable current capacity is accessed and set to 10 with myBottle dot current capacity equals 10. So the same variable is accessed again using the dot operator with the output from the printf command. You can also use the dot operator, the dot operator to initialize the structure if you'd like to declare it first without initializing it right away, such as this. So we got structure bottle myBottle. MyBottle.name is going to be this, the capacity, max capacity is going to be this, and the current capacity is going to be this. So this is instantiation, but it's done in a slightly different way. Okay, we got ads running on Twitch, so we are also going to run them on YouTube. Let's go ahead and play some birds. So I love the birds, and they keep me they keep me sane with their funny little antics. I love feeding them peanuts and seeds and seeing them gobble all the stuff up. Anyways, enjoy the birds. We'll be back in about 40 seconds, and then we'll continue on with our lesson. We're just going to take a little water break. And as usual, if anybody has any questions about cybersecurity or about anything else cybersecurity related, or what exactly we're talking about on the stream, let us know in the chat and we'll try to answer your questions and your comments as soon as we can. Okay, let's put the birds away. Let's continue on. So the dot operator is essential in enhancing the package benefits of structs by allowing you to access any of the bottle member variables through the variable myBottle. Okay, so what do we need to do? The workspace has a person struct inside the main function. Person 1 and person 2 are initialized as person types, and the names of each have also been set. So following the initialization and using dot notation, set the age of person 1 to 57 and set the age of person 2 to 27. Okay, so it looks like we instantiated these structs over here, but we forgot to instantiate their age value. So the name value has been set, but the age value hasn't been set. So we need to set the age value on these lines of code here. So person 1, we need to set their age to, what is it, 57. Vimax says, I don't remember setting up Poxmark, and somehow it's over 100 followers. Are you Poxmark? I've never heard of that service. Is that a social networking? Is that a social networking site? I've never heard of it. Let us know what it is. Okay, so we're gonna set the age of person 1 like this using the dot notation, and we need to set the age of person 2 as well. So person 2 dot age, we're gonna set this to 27. Okay, and let's go ahead and run this. And it works. Awesome. Okay, let's move on. Okay, so this is something I'm not really too familiar with, but we'll try to get through this as best we can. So we're talking about pointers, and this is one of the reasons I wanted to learn about C. Is I wanted to learn about all of the different funny little interactions you can do with pointers in the C language, because C has a lot to do with controlling program memory manually, and I really want to figure out what exactly all of these pointers do and how they can be manipulated. Okay, so structure pointers. Similar to other derived types like arrays and strings, structures can use a lot of memory. Imagine a structure with multiple strings, each able to hold hundreds of characters. One way to manage memory while working on data types of this size is to use pointers. As a reminder, a pointer is a variable that holds the memory address to another variable. For structures, this is accomplished by first defining the structure variable, then defining a pointer and assigning it to the address in the structure variable. Okay, so what do we got here? So we've got a struct called bottle, and then the object is called, the structure rather, is called myBottle. So it's a medium bottle, and it has these attributes over here, these membership variables. So struct bottle. Okay, this is a pointer. So bottle pointer, so that's indicated with this star. We're just going to call this one bottle pointer, and it's going to be the memory address of myBottle. So myBottle is this object here. Okay. So in the above example, bottle pointer holds the memory address pointing to myBottle. Okay. To access member variables with bottle pointer and the dot operator, we can use the following syntax. So we got pointer, bottle pointer.name, pointer bottle pointer max capacity, and pointer bottle pointer dot current capacity. So interestingly enough, when we do this bottle pointer, when we do these pointers rather, we need to encase everything in these parentheses here. So when using pointers, we need to dereference star, the address to access the variable it points to. So when using the dot operator with structure pointers, we also need to wrap the dereference in parentheses. Okay, so this is why we need to use these parentheses here. So if we simply dereference like a pointer.name, it will result in an error. So, arrow notation can also be used with pointers. Arrow notation can also be used with pointers to structures, as it implicitly does the dereferencing for you. Okay, so we've got a pointer and then arrow notation. So arrow notation is going to be the same as the dot notation, but it's done in a different way. Okay, so notice how much better the arrow notation reads compared to the dot notation. This notation is a clear and simple way to work with user-defined structure pointers. Okay, so what do we have here? The workspace has two person data types named person1 and person2. In the main function, we need to create a pointer to person1 called person1 pointer, and create another pointer that points to person2 called person2 pointer. So how do we create this? Oh, gotta keep the music going. Okay, create a pointer to person1. So pointer is it pointer struct or is it pointer person? It's pointer person1. Pointer person1 is going to be called person1 pointer. Hold on. So this is going to be a struct. Struct. So it's going to be a pointer for a person called person1. And let's see. We're going to call it the memory address of person1. And then it would be the same for person2. So copy paste. So this is a structure pointer. It's not something I completely understand, but I'll try to go along with it. No, that's not how you do it. Let's see. Looks like I need to struct and then okay. The star goes on the other side. Okay. Nope, still not. Let's see. Person2 is a pointer. Did you mean to use the... Hold on. What does this look like in up here? I need to take a look at the example. So, okay. So person... So, okay. The name of the struct, and then star. And then the name of the object. So that's person1. And equals... this looks like the right syntax. I wonder what's wrong with this. Let's see. Remove the word struct. Wuming Fang. Wuming Fang. Thank you. And okay, that's kind of weird because the word struct is in the example. But welcome to the stream. Okay, let's see if this works. Still doesn't work. Hold on. What is... Oh, we need to call it person1 pointer. Person1 pointer. Okay. Maybe person1 pointer and person2 pointer. Small potato. Hello, nice to see you here, Small Potato. Person1 pointer. Person2 pointer. And let's see. Let me take a look at the so it's supposed to be and ampersand person1 ampersand person2. You can't have... Oh, okay. Did I already... Hold on. I think I need the struct keyword here. Yeah, that works. This is like I said before, this isn't really something I have very much experience with. So I'm kind of learning how to create these pointers. Especially pointers. Well, okay, and structs. I'm not too sure what to do with the structs and the pointers. So okay, the next thing we need to do is make some changes to person1 after the pointer definition and using dereferencing and dot notation. After the pointer definition and using dereferencing and dot notation, add +1 to the member variable age of person1. Okay, where are we supposed to put this code? after the pointer definition, okay, so this is the pointer definition here. So after this, using dereferencing and dot notation. Okay, so it's dereferencing, so it's going to be is it this person1 pointer, and then wrap it up in person1 pointer and then age plus equals 1, or plus plus like this. So this, I wonder if this works. So person1 pointer is pointing to Martin, right? Martin is person1. So what we want to do is we want to get the output 58 for the age over here. Let's see if this works. Okay, that worked. That's worked. Great, great. Okay, so let's see. Now change the other structured data. Using arrow notation, add 10 to the member variable age of person2. So arrow notation looks like this. So a pointer, current capacity, or a pointer, arrow, and then something. So in this case, it would be person2. So person2, arrow notation, age, and it would be plus equals, right? So plus equals 10, like this. Nope. Okay, so what is it supposed to look like? So it was it's person2 pointer. It's person2 pointer. Person2 pointer. Okay, let's try this. I guess we don't use maybe we don't use the asterisk. Okay, that worked. Okay, let's move on. Structures and functions. Oh, geez. All right. So let's wrap up using structures with functions. We can specify structures and pointers to structures as parameters to functions. Structures as parameters to functions. Okay, so we got my function struct bottle B. Oh, okay. So my function, the parameters for my function are going to be the struct for bottle B, and then the struct for the pointer. Oh, we're doing pointers. Okay. So when passing a structure to a function, a copy of the structure is made so memory usage is a concern. Any modification made to the structure will not affect the original structure, only the copy. When passing a pointer to a structure, because the pointer is the address of the original structure, any modifications to the member variables will affect the original structure. Okay, so pointers will affect the original structure. What do we have here? We've got bottle function, which is a struct of bottle B, and a struct which is a pointer to bottle B called B pointer. We got b.name, oh, okay. So the name of the bottle object is B. Okay, so b.name is going to be super large, b.max capacity is going to be 100, b pointer name is going to be, b pointer to the name is going to be super small. It's both super large and super small at the same time. Okay, and then the max capacity is going to be 4. So I guess this is, hold on. What did we say? The pointer is the address of the original structure. Any modifications to the member variables will affect the original structure. So the pointer over here is going to modify the member variable name to super small instead of super large. and it's going to modify the max capacity to 4 instead of 100. Okay, so struct bottle 1, medium 24, 9, bottle B2, large 35, 9. So bottle function B1 and B2. So in the above example, bottle function has two parameters, a bottle structure and a pointer to a bottle structure. Inside the function, the structures are accessed the same way they would whether it is a structure or a pointer to the structure. The first argument is the call to bottle function inside main. It's going to be B1. A copy of the structure is made within bottle function, and no changes can be made to the values of B1 in main. The second argument in the call to bottle function is a pointer to, is the memory address of B2. The address, the address of B2, which any change to the member variables by using this address will change the values of B2 in main. So we can also return structures by setting the return type in the function signature. So let's see. So the type for this function over here, get empty bottle, which is void. Z zoo z zoo z z, is that your name? Welcome to the HackerFrogs and welcome to the stream. Let's give you a fun redeem. We're trying to figure out these this C programming. It's a lot of fun. How about hack the planet?
Hack the planet! Hack the planet! Shut up and
Okay, so we can also return structures by setting the return type in the function signature. So we can return the structures, return structure in this case, when we do structure bottle. So structure bottle is the return type for get empty bottle with no parameters. But it's got a structure. It's got a structure inside. Okay. So notice that structures as parameters and as a return type must use the struct keyword. This is confusing, and I'll probably be doing a lot of questioning when this stuff ever comes up in the actual C code. Okay, so the instructions. Time to look at different ways we can work with structures within functions. Sure. Define the function age1. Okay, so let's see. It's going to be age1, and we need to. This is a function. Okay, so give the function a return type of person. So it's struct person. Struct person. Age1, sure. And the body can be empty. The body can be empty. Okay, sure. That's easy enough. Remember to use the keyword struct throughout this definition. So it doesn't tell us what the parameters are for this function. So I guess we'll just leave it empty. Let's run that. Okay, that works. Great. Okay, so add some parameters to the age1 function definition. The first function parameter should be called friend1 and be of the type person. So inside the parameters here, it's going to be person, or is it struct person? Struct person friend1. This is already getting kind of complicated. And the second parameter should be friend2 pointer and be a pointer to type person. Okay, so that means the parameter should be struct friend2 pointer and be a pointer to person, to type person. So pointer to type person would be ampersand person friend2 pointer so struct let's see, this one should be a pointer to type person. Oh, no. No, we have to define it like this, right? It's going to be person pointer, like this. So struct person pointer, friend to pointer. This is making my brain hurt. Okay, let's see if this is valid. Okay, so that seems to work. Third step. Now modify the age member variables within the structures. Okay, so inside of age 1, we need to add 1 to the age variable in friend 1. So inside of age 1, these are the instructions. Add 1 to the age variable in friend 1. Okay, so the first instruction is going to be friend 1 dot age add 1, like this. Using the arrow format to dereference, add +1 to the age variable in the structure pointed to by friend 2 pointer. Okay, so to do the dereference, we need to, and we also need to use the arrow format. So the arrow format is going to be, oh geez. So this is the arrow format here. We need to friend 2 pointer. It's going to be pointing to age, and we need to add +1 to the variable. So it's going to be ++. I hope this is the right format. I'm a little bit unsure. Okay, the last thing we need to do is return the structure friend 1. So that's the last instruction. So return struct. No, it's going to be just return friend 1, right? Return friend 1. This is all very confusing. Okay, let's try running this. It might error out. Oh wow, it worked. Jeez. Okay, so now tested out, there are 2 structures defined in main to work with the function you need. There are 2 structures, okay? So inside the main function, call age1. Thank you very much, Truther. Welcome to the stream, and welcome to the HackerFrogs. Let's give you a desert frog. It's the cutest frog in the world. Okay, so what do they want us to do? So inside the main function, so where's the main function? It's probably down here. So call your function below. So this is where we're going to write our new code. Call age1. So age1. And assign the return value to my friend. Assign the return value to my friend. So let's see. My friend is here. Is this all we need to do? Set the first argument of age1 to my friend. Okay, we did that. Set the second argument of age1 to the address of my other my other friend. Okay, so let's see. The address of my other friend is going to be ampersand my other friend. Let's see if this is all we need to do. Hopefully this is all we need to do. Did you call age1 inside the main function and assign the return value of my friend variable? Okay, so when they say assign the return value of my friend, return value of my friend, hold on. Let's see. But we assigned the return value inside the function definition. So return friend1, for instance, over here. Call age1 and assign the return value to my friend. Is there something I'm missing? I think there's something I'm missing here. I mean, these arguments I understand. It's pretty easy to plug those in. But I'm not sure what it is actually asking me to do when it asks me to return assign the return value. So age1, my friend, my other friend. This is the function call. Hold on, let me take a look at the examples up here. Okay, bottle function, okay. Struct bottle1, struct something something. This is a function definition as well. Okay, we got ads running on Twitch, so we're also going to run them on YouTube. And we're going to take a little minute break while we have a little bit of water. So enjoy these birds. How about this woodpecker over here? Enjoy the woodpecker and the music. We'll be back in about a minute. Sorry about that. Jeez. Thank you very much, Cybernerd Dante, for pointing out that I'm muted. Okay, so let's continue. I really need to be more careful when I mute during breaks. Okay, so this is tough. Test it all out. There are two structures defined in main to work with the function that we created. Inside the main function, call age1 and assign it to the return value of my friend. Assign it to the return value of my friend. So does that mean that we do struct my friend and then age1 like this? Is this what it wants from us? No, that's not what it wants from us. So I'm gonna treat this like a learning experience, and I'm just gonna take a look at the solution and see what they actually wanted. Okay, so I mean this is I just did this a different way. This is essentially the same thing. But what was the other code? So the other code was my friend, my other friend. Oh, okay. They wanted me to do this as a variable. So they just wanted to create a variable called myFriend. Or wait, what is this? So myFriend is a struct. But why are we using the same thing as a variable name? I'm not too sure, but I mean, this is a function call, but I guess it doesn't return anything. Or does it? Anyways, let's, okay, we'll keep the code. We will put in, so all they wanted to do differently was they wanted this to be saved as a variable called myFriend. So let's see. Call age1 and assign the return value to my... Oh, okay. So I'm not too sure why they used the variable name myFriend, because myFriend is already the name of a struct in the person category. Omega says, can you share the link to your music playlist playing in the background? I really like it. Also, keep up the good work. My first time in stream, and I'm really liking it. You're very talented. Yeah. I'm struggling a little bit learning this C programming stuff, but I'll leave you the playlist. It's from a game called Valhalla, and it's about serving drinks to people in a cyberpunk setting. Let me go ahead and get the playlist. Just a second. Okay, so here's the link. There you go. Okay, let's run this. Now it works. Assign the return. I guess this is what they mean by assign the return value. Just make it into a variable name, right? Anyways, let's move on. Okay, so summary. So great job learning about structures. We've covered many important topics. So structures allow you to create user-defined data types. Structures can package together other data types into one type. You can define a structure using the struct keyword. When defining a structure, the member variables are declared but not instantiated. Structures help programs work with complex data and can represent real-world objects. Okay. You can access member variables with the dot operator. You can have a pointer to a structure and access its member variables using the arrow operator. And you can pass the structures and structure pointers to functions. Zahab-san, hello, nice to see you here. Welcome to the stream. And you should be able to redeem Hack the Planet. Psyched says, I have arrived. Thank you very much for gracing us with your presence, Psyched. Thank you very much for following Mike360. That's weird. You should be able to redeem the Hack the Planet. Let's see if I can do it.
Hack the planet! Hack the planet! Shut up and get it.
Yeah, I'm not too sure why your redeem didn't work so high. Nice to see you here. Okay, so we're just do not redeem the card. Loving the InfoSec content. What's your background? So I used to work in web app security testing, and I did that for about half a year. And I decided I wanted to do teaching instead, so I decided to pivot. And now here I am. I'm teaching cybersecurity stuff on Twitch and YouTube. Okay, so all right, so with our understanding of structures, we can now create and work with complicated data types easily and efficiently. Okay, so use the code in the workspace to play around with the structures. What can you add to the person structure? What are some functions that would help act on the structure? So I think we're going to press the I believe button, and we're going to finish up this this course. Let's see. Do not redeem the card. Do not redeem the card. I'm not too sure what you mean by do not redeem the card, but anyways. Okay, let's go ahead and skip. Next steps, you successfully completed the C Functions and Structures course. You learned how to incorporate functions and structures into your code to write more complex and powerful programs. We are excited to see what you can accomplish next. Okay, so do they have a quiz or something for us? I guess they just ask us to rate the program. Sure, it is really good. Share your thoughts. I prefer not to. Please fill this in. No comment. Please enter your first name and last initial to display with your review. Let's see. The Shy Hat. D. Is there anything we can do to improve the experience? Can we skip? Let's just skip this manually. What's going on in chat? I used the Hack the Planet for real. Let's see, just testing the skills. What is disk image forensics? Oh, disk image forensics. So we did our lesson on disk image forensics at the beginning of today's stream. And if you're watching on YouTube, you can go back to the beginning of the stream and take a look at that content. We were working with PicoCTF, and let me see if I can. Let me see if I can get the link for the live stream. So the link to the live stream on YouTube is over here. I'll leave the link in chat. You can go back to the beginning of the live stream and take a look at the digital forensics stuff. So we did that for about the first hour and a half. And how many hours are we into the stream? We're currently in hour 2. We've been online for about 2 hours and 17 minutes. Okay. So let's go on. Let's go ahead and talk about what we're going to be doing next. So next Friday, we're going to be moving on into the difficult part, the difficult part of learning C, and because we're going to be doing this course over here. So the course is called C Pointers in Memory. So this is actually what I really wanted to get into when I was learning about C. Should we do C Pointers in Memory, or should we go back and finish this one over here, arrays and strings? I don't think we need to do very much with arrays and strings. We can probably pick it up ourselves, but this is going to be this over here. So ZZZ, can you give me a simple idea of what it is? Yeah, okay. We've got our PowerPoint that we were using earlier today, and let me go ahead and give you a couple of So digital disk image disk image forensics overview. So what is disk image forensics? So disk image forensics is the examination and analysis of information stored on digital disks, such as hard disk drives, USB drives, or any other type of storage media. C is tedious. Yeah, but we need to get through it because it can unlock some really cool stuff if we understand it. Let's see. Digital disk forensics is often used in cybersecurity incident response to analyze and identify devices that may have been compromised in security incidents. So we're taking a look at the Sleuth kit software, and the Sleuth kit is a popular program used in digital disk forensics, and we can use it to access it from the PicoCTF web shell. So the platform we've been learning about digital disk forensics, we've been alternating between TryHackMe and PicoCTF. PicoCTF is a really great cybersecurity education platform. If you don't have an account over there, you can make one over at this link. Critical to know. Yeah, well, if you understand C, then you're going to understand a lot of other stuff that's related, and like stuff like Linux and I think Python was originally coded using the C language as well. So we were learning about some basic operations of the Sleuth kit in that previous workshop to learn about digital disk forensics. So we did like 3 different challenges from the PicoCTF website, and we learned some different commands with the Sleuth kit to take a look at the information inside of these digital disk images. So yeah, that's what we did for the first part of today's stream. Let's see. J Mike says a lot of Python libraries are wrappers around a FFI layer. What does FFI stand for in this case, J Mike? Let us know. Okay, but yeah, let's So we're going to be doing this C pointers in memory course next week, and yeah, it's going to be. I don't know if it's going to be a lot of fun. It's probably going to be a lot of pain, but. Foreign function interface. Okay, I have never heard of that term before, but thank you for letting us know. But let's go on. Let's go ahead and start our last part of today's stream. And the last part of today's stream is we're going to be doing some Windows hacking. So we got this challenge that we've been doing over the last 3 weeks. It's called Pila, and Pila is a Spanish word, and it means stack or pile. And this Windows challenge has to do with binary hacking and buffer overflows, stacked buffer overflows in particular. We've been working on this thing for, I don't know, at least 6 or 7 hours already. And today I'm going to try to finally get through and do that binary buffer overflow hack. Pila also means battery in Spanish. Oh, that's great. Well, I mean, that makes a lot of sense that there's a battery over here as well. So battery and pile and stack also, they all mean the same thing? Okay. All right. Yeah, so to do this, we've been doing a lot of research over at TryHackMe. So TryHackMe's got a very convenient room for learning about stack buffer overflows. Let me see if I can get it. So this is going to be a free room that you can access as well, and it's actually very good for teaching stack buffer overflows in a very systematic way. Let's see, it's called Buffer Overflow Prep. Okay. Buffer Overflow Prep. Yeah, so this is the link for anybody who's interested in taking a look at it yourselves. You can access this room for free. You don't need to have a paid subscription over at TryHackMe. But we're not actually covering the material in the room. We're just using the machine that comes with the room as a test machine for doing our buffer overflows on this Pila challenge over at the Hackers Labs. And if you want to take a look at this challenge yourself, then this is the link where you would do it. But anyways, we're going to start the machine over here. So we're going to deploy the VM, and we need to access TryHackMe via a VPN key. So after we VPN into their network, then we can access this room. So I think I have... Hold on. Just got to make a bunch of tabs over here. We're going to move into our downloads directory, and I think my VPN key is there. Okay, so I think this is it over here, the shyhat.ovpn. J Mike asks, do you do these challenges ahead of time or solve them live? So I solved some of them ahead of time, and I solved some of them live. This is one of the challenges that I've been solving live, and that's why the challenge has been taking 3 weeks. This is my 3rd session doing this particular challenge. But I do other demonstration challenges, and those don't usually take nearly as much time. But anyways, let's go ahead and log into the TryHackMe network right now. So that's going to be sudo openvpn with this key. Okay, so we should be connected to the TryHackMe network, which means we should be able to access this machine over here on this IP address. So I'm going to try to ping the machine just to make sure that I can access the thing. JMike says, I think if people have the patience, it's great to see the process. We've been hitting our head against the wall for quite a few hours now, but I think I've got a breakthrough for this challenge. Hopefully, everybody's being entertained by me suffering through the process. But anyways, let's go ahead and ping this machine. So we just need to make sure that we can communicate. Yeah, it looks like we're connected. So on this network, this is the ton0 interface that I've tunneled into, and this is our IP address on this network. Okay, so from here, what we're going to do is we're going to log into the Windows machine. This is a Windows test machine that we're going to be using, and I think so. This is our OpenVPN tab. I'm just going to rename it OpenVPN. We're going to give it a funky color. How about we make this red? And this next tab over here, Aqua, hello, nice to see you here. It's morning. It's morning. Are you in Europe or are you in Asia? Aqua, let us know where you are in the world. Okay, so from here, what we're going to do is we're going to access this machine. I think it was which command did we use to access the machine? It wasn't remina. It was some program that we could use for remote desktop. I think it was our desktop. Yeah, our desktop. Okay, we just need to use our desktop with the IP address. And what was the IP address? This one. Okay, so we do our desktop. Okay, and we log into the Windows machine. Oh, Sri Lanka. Okay, awesome, awesome. Sri Lanka. I've had Sri Lankan food before. It's really good. It's really good. Really good spicy curries and such. And I think we need to use another user. And I think it's the login is going to be admin and password. Let's try that out. Okay, we're connected now. So we got to wait for this to boot up. This is a Windows 7 machine. I think our target environment is also running a really old version of Windows as well, so this is going to be okay. If we ever meet one day, let's get some good food. Yeah, you know what? That's a good idea. If you want to ever make friends with somebody, just go out and get some good food with them. Okay, so let's see. I think we can make this bigger. We're going to be using Immunity Debugger to access the machine. So the couple things that we need to do, we need to move our vulnerable test binary and its associated DLL file over to this machine. So let's see. Let's go ahead and do that. I think we can create a file. We're going to call this one vulnserver.base64 or .b64, because we're going to move the binary over by clipboard. This isn't a very graceful technique, but this is a technique that I use to move around small files, especially binary ones. Let's call this one our desktop. Okay, make this a color. Let's make it purple. Yes. Okay. So the binary that we're going to be testing is in the downloads directory on my Kali Linux machine. So it's this server, this binary right here. It's called vulnserver.exe. And the reason why we can't test this out using our regular testing methods is because this is a Windows binary. Let's see, JMike says, always the worst part of the lab, how to get the file to where it needs to go. File transfer can be tricky sometimes, but here's the technique we're going to do. So if we just do cat vulnserver.exe, then we get a bunch of unprintable bytes. So this isn't, we can't move this stuff over. So what we're going to do instead is we're going to pipe this into base64 to encode it into base64. So we can move this over the network. So I'm just going to cheat a little bit. I'm going to make the terminal text nice and small so that I can scroll up to the top of this output more easily. So after that, we're going to copy this all over to our clipboard. So just copy, go down to the bottom. Come on. Okay. Done. Copy selection. Do I have xclip? I don't think I have xclip on Kali Linux, but you know, that's a pretty good idea. I could probably move the stuff around a lot easier if I used xclip. Hold on, I need to change my music up. Let's play some moody music from this sci-fi game here called Independence War 2. Okay, awesome. Okay, so we just copied this over to the clipboard. We're going to paste this into our Windows machine here in this file called vulnserver.b. It's supposed to be b64. Okay, we're going to open it up in Notepad. Then we're going to paste in the contents. So there's a lot of stuff here. The last thing we need to do is we need to convert this from base64 back into its original format. But we're gonna, before we do that, let's go ahead and create the other file we need to move over as well. So there's an associated dynamic link library file that we need to create as well. Let's go ahead and create the base64 for that as well. So it's going to be called essential ESS func .base64. Okay, and let's get the base64 version of that as well. So it is ESS func.dll. So we're just going to cat that out, base64 encode it, make it nice and small, go up to the top, and then copy all this stuff. Is there any setup needed before being able to use clipboard on the remote machine? Well, no, not for this machine. For some other machines, maybe yeah, but not this one. Okay, so make sure we're only copying exactly what we want. Then we can go back to the Windows machine. And in the Windows machine, we're going to paste in the base64 contents, save it out, and then we're going to go into the to the terminal to create our file. So this is just going to be cmd.exe, and we're going to use certutil. Actually, I forget which certutil command to use. Just a second, I need to look this up. So certutil base64 decode. Okay, so I think the command. Let's. We're not going to be using this this window for very long, but you know, while we're here, we might as well make it nice and big so that everybody can see what's going on. So properties, font, let's make this 22. Can we make this bigger? 10 by 18. Okay, so this is bigger. Now we can see. The command is going to be, I guess we need to go into the desktop directory. Okay, so we got the base64 text files. We just need to do cert util decode vuln server dot b64 dot txt, and the out file is going to be vuln server dot exe. Okay, and we're going to do the same thing for the essential function file. So this is going to be essfunc.dll, and the file is called essfunc.b64.txt. Okay, so we now have a vuln server ex executable and a vuln server dynamic link library here. Zen says, I'm new to cybersecurity. Do you have any recommendations? Like, what should I start with? Zen, yeah, no problem. Let us know what experience you have already, and then we can better identify where you should start. Because, well, the first thing you need to do is you need to figure out what role you'd like to aim for in cybersecurity. If you want to aim for like a pen testing role, or if you want to be in the security operations center as a SOC analyst, or if you want to be a digital forensics person, figure out which kind of job that sounds the most exciting to you, and then let us know what technical experience you already have. So do you have experience with developing applications, or doing or coding or programming? And then we can tell you where to start. Globby Guy says, what kind of skills are somebody who works on an Active Directory team? So Active Directory team, are you talking about a person who works in Active Directory as an administrator, or what role do you do with Active Directory? Let us know, Globby Guy. Okay, so we've copied these two files over, and we converted them back from their base64 to their original forms, so we can use them now. So we're just going to run vuln server over here. Double click, run the thing, and we're going to connect it to immunity debugger. So we're going to start up an immunity debugger, and we're going to connect the file. So we're just going to do, what is it, file attach, and we're going to attach vuln server. Where is it? Oh, the font is so small. There it is. There it is. Okay, attach. Okay, so we're going to be using Immunity Debugger to figure out how we can do buffer overflow on this particular binary. So we're just going to, let's see, we're going to run the program. And now we can access this from the network on port, I think this binds to port 9999. Let me go ahead and confirm that. So this is the IP address. We're just going to do a quick scan with Nmap. Actually, no, we don't need to do a quick scan with Nmap. We just need to access port 9999. So it says, welcome to the vulnerable server, enter help for help. So this is the binary that we need to do our buffer overflow on. And we spent a lot of time trying to figure out which one of these functions we need to try to overflow, because the overflow could be in any one of these program functions. And I think we narrowed it down to this trun function over here, trun. And so to do that, we're going to be using some of the scripts that are provided in the room over here. So the room it basically teaches you about how to do binary buffer overflows. And I think the scripts that we can use are located in this first section over here. JMike says, did you disassemble to find the vulnerable method? Did we disassemble to find the vulnerable method? I think we just did a lot of fuzzing to find the vulnerable method. And actually, I'm going to do some fuzzing just to make sure that that this is the correct thing that we were supposed to identify. We actually identified a few different crashes that we could potentially do the buffer overflow on. The problem was that they didn't provide us with enough room to insert our malicious code. So that was kind of a bust. So we've got this Python script here. Let's get out of here. Okay, let's move into our temp directory. And let's call this fuzz.py. Okay, this is the script we're going to be working with. This is going to be Python 3. We need to insert an IP address. I think this is the same IP address. That's fine. The port is going to be different. We're currently working on port 9999. And I think the function that we're going to try to overflow in this case is the trun function. So we're just going to feed it a bunch of data. So for example, some A's, and we're going to send it 1,000 bytes at once, and then we're going to send 1,000 more bytes every time we communicate with it to figure out where it's going to crash. So if we can figure out where the crash point is, we can try to narrow down how many bytes we need to send to the program to get control of the instruction pointer for the binary. So let's go ahead and save this out. And let's run fuzz.py. So we send 1,000 bytes, 2,000 bytes, 3,000 bytes, 4,000 bytes, 5,000 bytes, 6,000 bytes, 7,000 bytes. Wow, we're sending a lot of bytes. Hold on. Something's wrong with this environment here. Let's try sending a lot more bytes to see if we can actually cause a crash. We'll keep on sending thousands of bytes. We'll keep this going for a little bit. And we'll see, this is all being handled inside of the immunity debugger. We see that the program is running. Eventually, we'll send so many bytes that it crashes. Well, that's the theory, anyways. My concern is that if the actual machine is running with a different version of Windows, then the program crash could be at different points during the program execution, and that whatever I'm testing over here isn't going to work with the actual program, and in that case, that would be very, very bad. Zen says, I know Python and a little bit of Java and currently working on CompTIA A+. My goal is the pentester role. Okay. So let's see. So Zen says, no Python, a little bit of Java, working on CompTIA A+. So it sounds like, here's what I would recommend to you. So I've got my YouTube channel over here, and the YouTube channel has a bunch of playlists. So I would start with the PicoCTF playlist. So PicoCTF, we've got 96 different challenges over here. And what I would recommend to you is to try out these challenges. The earlier ones, they're going to be very very, very easy depending on how much you know about computers and technology in general. In which case, you should try solving all these challenges without taking a look at the video walkthrough, and then keep on working through these challenges over here. And eventually, you'll come across some stuff you don't know. Try it out yourself before looking at the video at the walkthrough video. There's no shame in watching or following a guide, especially if it's a subject that you don't know anything about. I come across technologies that I know nothing about all the time, and in that case, I have to do a lot of research to figure out what the solution is for these challenges. So let me get the address of the playlist. I'll leave it in chat. There you go. Give that a go. CompTIA A+ is a very good thing to study if you want to get into technology in general, and so I'll recommend a channel that does A+ content. That's Professor Messer. Professor Messer, where is it? And Professor Messer has an A+ playlist over here. So A+ training course. Let's go ahead and get the full list. So this is a playlist for Professor Messer. There you go. The videos are very easy to follow, and you can. These are intended for people who want to take the A+ exam. You don't necessarily need to get certified to learn about this stuff. In fact, if you don't want to get the certification, that's fine. Just study the materials, because the materials have a lot of good information in them if you want to learn about technology in general. But anyways, okay, this is what I'm going to do. I'm going to start up the actual virtual machine that I'm fighting against, quote unquote fighting against. Let's see, it's Pila. Here it is. Let me start it up. Zen says, thanks a lot. No worries, no worries. I'm here to help people out. If you find it helpful, then I'm happy. Okay, so we've got our Windows machine. It might be that that I'm kind of barking up the wrong tree, because the Windows versions might not be compatible. So this is Windows Server 2008. And the test machine that we're working on is Windows 7. Server 2008 and 7 are roughly the same version of Windows, right? Hold on, I need to figure this out. Windows Server 2008. Okay, so the question, I guess I'll ask the AI. Are Windows Server 2008 and Windows 7 roughly the same? Roughly the same. Okay, so Windows Server 2008 R2 and Windows 7 share a common code base, so they have many similarities. But let's see. 2008 R2 is designed for client-server computing, whereas Windows 7 is designed for individual users. Okay, so let me see if I can locate this machine on the network. I've started it up. Let's see, so this should be on the ETH1 network. I don't have an address for it right now, so I need to DH client and get myself an address on the network. Joe Vasco. I'm new and I want to learn cybersecurity. Okay. YouTube recommended you're live. Hello, Joe Vasco. Nice to see you here. And yeah, if you want to learn about cybersecurity, let me know what you already know. Because if I know what you already know, then I can better give you advice on how to get into cybersecurity. Do you have you worked with technology before? Do you know how to do development? Have you created web apps? Have you done coding before? Let us know what you already know, and I can give you a better. I'll have a better idea of where you can go from there, or where you are. Okay, so I should have I should have an IP address for this network now. So I'm at IP address 56.4. Okay. Well, let's figure out where this machine is on the network. So we're going to nmap. We're going to do a ping sweep for this network. And it looks like our target machine is probably on the number 3 address. So let's nmap this IP address. And I'm going to check if port 9999 is open, because this is where the vulnerable service is. Okay, so port 9999 is available, so we can probably fuzz that that particular port. Anyways, we've got our fuzzing program in the temp directory, right? Fixit42 has just rated the channel with 5 viewers. Hello, welcome raiders, and welcome Fixit42. What were you all working on Fixit's channel? Let me know, and let's do a special video redeem for Fixit and the raiders. How about all the things? Drink all the booze and hack all the things.
This one's dedicated to all the hackers.
Okay, welcome raiders. And yeah, anybody who's from Fixit's raid, welcome. My name is the Shy Hat. I do cybersecurity content over on Twitch and YouTube. I have a YouTube channel. I'm especially enthusiastic about helping beginners get into cybersecurity. And yeah, so Joe Vasco, if you're still there, let us know what you already know about cybersecurity so I can help you out. We did an HTTP box, a rabbit hole heaven in okay. Hack the box is it's tough sometimes. It's tough most of the time. But anyways, so we've got this machine. We're going to try to fuzz the service to try to figure out if we can crash the service using a certain function. So I'm just going to take a look over here. So the IP address has changed. Hold on. What was that IP address? It's going to be the 3 address. Okay, over here. Globby Guy says, is cybersecurity off the table if you haven't done coding or web apps or development? No, it's not off the table. It's not off the table at all. You can teach yourself some basics of coding. You don't necessarily need to be really great at coding to do cybersecurity, but it is recommended that you learn how to read code to a certain level where you can at least try to understand what the code is doing, because you will encounter code every once in a while. You're not going to be staring at code all the time, but when you encounter it, you need to be able to parse the code and understand what it's doing. You don't need to learn a bunch of different languages, mostly Python and maybe 1 or 2 other languages depending on what your specialization is. But you don't necessarily need to be like really good at coding. That's kind of a misnomer. All right, so let's see. We need to replace our IP address. This is the IP address we want to test. Okay. So let's run the fuzzer. So 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 8,000. Am I doing this wrong? Because it looks like we're fuzzing with a lot of bytes, but it's not really crashing. Let me try another function in the program. So there were a number of different functions that we could access. Let's see. Fixit42 says, "Good night, so tired." 14-hour stream. Jeez. That's what were you? Wow. I hope you weren't spending 14 hours on the same Hack the Box machine, because that seems a bit extreme. But yeah, have yourself a great night, Fixit42, and get yourself some sleep. Jeez. Seems like too much. Yeah. I guess we need to use a different. We need to use a different function. So if we use netcat to connect it to the machine, we need to test these different functions here. We started with installing the new laptop. Oh, I hope that installing the new laptop went okay. Because it's yeah. And what did you install on the laptop? Is it Linux, or is it Windows, or is it something else? I'm guessing it's just it's Linux. Let's see. Not Just Fun says, "What is your knowledge on cloud security?" So cloud security, I've done a few different modules on AWS. So if you're looking for AWS testing, you could go to, oh gosh, what was the name of Contra Security? AWS Top 10. And this is a great little training course that teaches you about AWS security testing. So let me get the link over here. Let's see. It was Windows 11. I don't think I'll keep it. You want Kali Linux for your laptop, of course. But yeah. So AWS Top 10. This is really good for doing basic testing against S3 buckets or E2 instances and stuff like that. And another good resource for cloud pen testing is something like FlawsCTF. So this one over here, so flaws.cloud. This is another CTF challenge where you can take advantage of a bunch of AWS misconfigurations. So this is the link for that. Okay, so trun isn't the one. So maybe we can test srun instead. Let's go ahead and try that. So we'll disconnect. We'll use the srun function instead. Okay. Now let's run the fuzzing program. 2,000 fights, 3,000, 4,000, 5,000, 6,000, 7,000. Okay, so something tells me that it's not this one either. Actually, you know what? Maybe we can increment it by 10,000 bytes, and we'll find a crash really quick if we send 10,000 bytes. I just want to figure out what function is going to cause a crash in this case. What were the... So that's srun, trun. Thank you very much, Not Just Fun. Subscribe with Tier 1 on Twitch. Wow, thank you very much, Not Just Fun. Welcome, and thank you very much for the subscription. Why don't you have a... I'm root. Because sometimes we root the machines.
What are you?
I'm system root.
But yeah, I personally haven't done very much with cloud security stuff, but I did have to test some AWS integrated applications when I was doing web app pen testing, and sites like the Contra site were very, very useful when I was doing that, because it let me know the common misconfigurations for stuff like S3 buckets and other stuff like this, like, you know, dependencies or misconfigured proxy servers, etc., etc. Let's try... I don't even know. I've tried all of these over the last few weeks. Let's try... Let's try Gmon. I'm sending a lot of bytes, but it's still not really crashing. So it's okay. JMike says, "Is flaws.cloud good for practicing network attack techniques in general?" Flaws.cloud, it's good for doing AWS stuff, but what kind of network attack techniques are you looking to practice, JMike? Because if you let me know what kind of stuff you want to learn, then maybe I can better point you at some resources that'll teach you that stuff in particular. Hold on. Let's try 500. Okay, leave this on for a little while. We still have our desktop over here running Windows. Let me see how much time we have remaining on that box. I think we start with like 2 hours on it. Yeah. Oh, we only have 21 minutes left. We should probably add another hour. So, I mean, the flow for doing buffer overflows is to first figure out which function in the program is going to be vulnerable to the buffer overflow. Then we need to replicate the crash and try to figure out exactly how much of an offset we need to send before we can control the EIP or the IP. The IP, what is it called? The pointer, to get our remote code execution off. So this is what we're trying to do. I think there must be something we're doing wrong. There must be something we're doing wrong. Not Just Fun says, for somebody starting out, would you recommend try hack me, then moving on to hack the box, or the other way around? So usually the pipeline goes from, I would start with PicoCTF, and then I'll go with PicoCTF and or try hack me, and then after you get a certain amount of proficiency, moving on to stuff like hack the box. So hack the box is not very well known for being beginner friendly, but it's definitely something you want to work your way up to, because a lot of people swear by hack the box, and they actually have a path for learning. Hold on, I need to change my music out. Let's play some Faster Than Light. Here you go. Okay. But yeah, Hack the Box has a beginner's series of rooms that you can try, and it's completely free, which is nice. Where there's a lot of stuff on, there's not a lot of free stuff on Hack the Box, but the starting point, which is this series of videos over here, they are free, which is nice. So this is the link for my particular YouTube playlist for this, and where we talk about how to finish those rooms. Okay. J Mike says, looking for resources for practicing man in the middle. Okay. DHCP spoofing, ARP cache, poisoning, DNS spoofing, etc. Techniques for tunneling, pivoting, and doing network reconnaissance. So you probably want to do some stuff on TryHackMe, because TryHackMe has modules on this stuff. I think the modules you're looking for might not be free, but actually wait. There is one place where you can do some pretty good stuff over on TryHackMe that does have to do with pivoting and tunneling and stuff like that. And let me go ahead and get that for you. So I think the network is called the Wreath Network. And the thing is that in order to use this for free, you can use this if you pay, but you can use it for free if you have a streak. If you use TryHackMe for 7 days in a row, you can get access to this network without having to pay. I'll get the link for you. There you go. I don't think I have access to it right now, but it does teach you a lot about a lot of stuff. It's got 3 different machines that are connected together, and you can do a lot of tunneling and stuff through those. Another thing that you could do, if you just want to learn about tunneling, is... Hold on. We got ads on Twitch. So when ads come on Twitch, we need to do them on YouTube. And let's put on some birds to look at while we're doing our break. How about these birds? Okay, so we'll be back in about a minute or so. Just hang on. I'm going to take a little water break. So this is a lovely northern flicker woodpecker. You can tell it's a male woodpecker because it's got a red mustache. So these woodpeckers either have red mustaches or black mustaches, depending on where you can find them in the country. They're native to North America. And let's go ahead and put the woodpeckers away. Get back to the hacking. Okay, so yeah, JMike, if you want to learn about pivoting in particular, there is one good resource over at the hackerslabs.com. The Pajaro88 asks, do I have a cyber deck? By cyber deck, what do you mean? Let me know, the Pajaro88. And welcome to the stream. Hey, nice to see you here. Let's see. What are we doing? We've got there are some pivoting labs over on the hackerslabs.com. It's a Spanish language site, but you know, if you know your technology stuff, the language barrier really shouldn't get in the way. And I've worked on this this box over here. It's called Happy Jump, and this is a box where you have to pivot between the base virtual machine and there's a Docker container that's inside of it. So you do your pivoting through into the Docker machine that's on the Docker network inside the machine, and it's actually pretty fun. Let me give you the link for this. JMike asks, is it TOS to stream solutions to such TryHackMe modules? Hack the Box has rules, but I don't know about other platforms. I don't think TryHackMe has so many rules about what is allowed and not allowed to be streamed. I think the rule's supposed to be you're not supposed to put out videos if there are less than, if nobody has completed the room yet, usually that's not really too much of an issue. But I think you can stream, I think you can stream TryHackMe stuff. It shouldn't be too much. If they have a problem with it, they'll tell you. Well, they'll probably tell you by flagging your videos. But yeah, this is a pretty good resource over here. Let's see. I've seen many do-it-yourself cyberdeck videos on YouTube. They look hardcore. Huh. What is a cyberdeck? What's the difference? A cyberdeck is a personal mobile computer found in many. So is a cyberdeck just a modified laptop? Or it's a portable computing device. Oh, okay. So, I mean, I hope this doesn't lead to anywhere weird. Okay, so what is a cyberdeck? So it's like building a custom desktop tower PC. A cyberdeck is all about giving you total control about every piece that goes into a portable computing device. Is this what we're talking about? So where does the name come from? So cyberdeck is given in who doesn't like hanging out at the local cafe. What can be found here? So if I type cyberdeck, huh? Let's see if we can find any really cool images on Google. Oh, okay. So it's like an all-in-one, like, little computing device, right? Is this what you're talking about, Pajaro88? Let us know if this is what we're talking about. I mean, it does look very cool. I don't know if I would be able to build stuff like this. Well, I can't. I certainly don't have the capability to build this. I already have a really expensive laptop computer. I think I've got a framework computer, and it's not even like the most up-to-date framework computer, and it cost me like close to $3,000 Canadian, which I guess would be something like $2,500 USD. It's a really expensive laptop. But yeah, these look very, very cool. Don't like I said, don't know if I'd be able to get this working on my own. But yeah, let's go ahead and thank you very much for letting us know about this stuff. Jeez, it does look super cool. But yeah, we got let's see, pivoting labs, we got cyberdecks, we've got the Wreath network. So the Wreath network is probably this is probably the best way to go about it, because they have a lot of information here that teaches you about pivoting and stuff. So pivoting, they've got a whole section over here. It teaches you probably know about pivoting already. They teach you how to do pivoting with proxy chains, with SSH tunneling, with a bunch of different pieces of software like Plink and SOCAT and Chisel. This isn't super modern. I think there are a few like modern networking tools that people use for pivoting that have become popular in the last 2 or 3 years. But it still teaches you a bunch of techniques for pivoting. And I think they also, I don't know if they've got a lot of man-in-the-middle attacks or not, but you can probably learn that somewhere else. Hope this works. I mean, I hope this helps. Yeah. What were you doing? So I was informed that that the TRUN function is the one that we want to target. The problem is that we can't get the crash to occur. I think what we need to do is we need to approach this in a different way. I want to manually try crashing the service first. So let's make a pattern. Let's make a pattern. So RGG. Hold on. I've got some write-ups where I use this tool to create some patterns that we can feed to vulnerable binaries. But I keep on forgetting the syntax for the command. Sleepy Dude, hello! Sleepy Dude, hello! Nice to see you here. We're just doing some cybersecurity stuff over here. We're also giving advice. If anybody has any questions about where to get their cybersecurity stuff, where to do their training, I'm here to answer questions about that if you have them. So reg, we're going to do, let's see, a pattern. Let's do 5,000 characters. Actually, let's do 6,000 characters. Okay, so this is 6,000 characters. We can feed this to our application and see if it crashes. What is the IP address? So the IP address is this one right here. Let's try netcatting into it. Okay, so trun and then the value. So trun srun, trun, gmon, gdog, kstat. Man. How about case? I don't know. So stats worked. R time. R time, L time. srun, trun, srun. Gmon. gdog. gdog, kstat. Okay, that crashed. I think that crashed the service. So let's see if we can communicate. Oh, okay. So that crashed the service, but it's back online. Okay. Could have just crashed the thread. Well, I mean, let's try our test machine over here. So the test machine is very, very similar because they're both based off of Windows 7. But the thing is that I'm kind of paranoid as to whether or not the number of bytes that we need to send is going to be. Could have crashed the thread, which would still be a success. If we crash the thread, we can still use that for buffer overflow. I'm pretty sure. Okay, let's send it to this IP address instead. So this IP address is this one right here. Let's copy that. Let's run our fuzzer. And the command we used was kstat. Okay, let's fuzz the ever-loving heck out of this thing. So python fuzz.py. So we send 500 bytes and it crashed. It crashed with 500 bytes. Let's take a look and see if it crashed. So It says it's still running. Hold on. Let me double check. So this is... Oh. Hold on. Yeah, I need to change my IP address. So I'm going to be using the test machine. Change out their IP address. Okay, so this, if we crashed it, then over here, yeah, this is a crash. So we need to figure out exactly how many bytes we need to send to crash this program. Let's see. We can restart the program, and then let's try again. Oops. We're going to go back into the fuzzing script, and we're only going to send 100 bytes at once. We're going to see how many bytes it takes to crash the program. Okay, 100. We only need to send 100 bytes? We need to send less than 100 bytes. Hold on. So oh no, we didn't. Yeah, okay, we crashed the program. We've got a bunch of 41s in the EIP here. Okay, let's reset the program. Hold on. 2. Okay, so we reset the program, and then we send it very, very small, a very, very small amount of bytes, just to figure out where the crash point occurs. So let's nano, and we'll send it 10 bytes at once. We'll just send 10 bytes at a time. Okay, so 10 bytes, 20 bytes, 30 bytes. So it crashed before 100. 70. So it looks like it crashed before 70 bytes. So we can start at 70, we can start at 60, and we can just send 4 bytes at a time. Okay, so we're going to start at 60. And we're going to send 4 bytes at a time. Okay, we need to reset our program over here in the Windows machine. And let's, whoops, keep on doing that. Okay, let's run it again. Whoops. 60, 64, 68. Okay, so we sent 68 bytes and it crashed. So let's take a look and see if what we have in here. I need to make this nice and big. It's hard to see this font. Let's do Courier. Okay, that's a little easier to read. So the EIP now has it. I don't think we were able to put anything in here. So what I'm going to try to do is I'm going to try to send go back in here. So we know it is going to crash with 68. So we're going to try to send 64. And then we're going to send 1 byte at a time, just to figure out exactly where it crashes. It crashed at 64 bytes. It crashes at exactly 64 bytes. Does it? Okay, so this crashed. But we don't see anything we don't see any output in the EIP. So, So we're going to move on to the next part of the enumeration here. So the next part of the enumeration involves us doing crash replication and controlling the EIP, and they've got a script for this as well. So let me grab the script. Let's go ahead and create this. Let's see. Sorry, I haven't been paying attention to chat. Let's see. JMax says, could the send a big offset pattern? With a small payload, we could be just causing a seg fault with a random overwritten variable. So I think what we need to do is we need to figure out if we can enter information into the EIP, and then after that, this is not very much room. We can't send any shell code. We can't send any malicious code with only this much room. So we need to find, I don't know, I think we should abandon this one. Because there's so little room to work with here. I don't know. Let's see if we can find another function that we could take a look at. We did see an EIP value with 41, 41, 41. Let me demonstrate. So I think if we send I think we'll see it appear. So I think it's 64 crashes the program. But if we want to enter the EIP, I think we need to send maybe 8 more bytes. So 64 to 72. Let's just try sending 72. If we send 72, we should see some input in the EIP. Let's reset this. Okay, we send 72 bytes. It crashes the program. We see 2 41s in here, so that's 72. I think if we send two more bytes, we should completely control the EIP. So let's. But then again, I don't think this is the function we want to do, because there's no room for malicious code in here. Cyber Snail, welcome to the stream. Jeez, why don't you have a Hack the Planet? Hack the Planet. Welcome to the stream. You are now HackerFrog.
Hack the planet! Hack the planet! Shut up and get it.
Okay, let's save this out. We were actually taking a look at this function to do buffer overflow last time, and we came to the conclusion that that this wasn't what we wanted, because there's no place for us to put our malicious code after, well, either before or after controlling the EIP, which means that we can't really use it. It's kind of a bust. But let's reset this thing. JMax says, does the crash behavior change if we send data beyond the EIP? Sometimes we'll get different crashes if we send differing amounts of data. But in this case, I think... Hold on. I'll demonstrate why we can't use this particular function. So we're going to send, I don't know, let's send something big. We'll send 200. We'll send 200 bytes. We only need like 64 bytes, but we're sending 200. And I'll demonstrate exactly why we can't use this function. So we crash the program. and then we follow the ESP and we follow it in the dump. So the ESP is, let's see, E0. E0 is here. The thing is that we only see our A's for about 15 bytes. For about 14 bytes after the EIP, and then it all gets replaced by random bytes. So we can't put our malicious code after the EIP, and we can't put it before the EIP, which means we can't really take advantage of this. I tried sending it like a lot more, but the input doesn't get put into the memory regardless. It just kind of like disappears after the next 14 bytes after the EIP. So we need to find something else. Cybersnail, hey, and Cybersnail NOP, no operation, right? Cybersnail no operation, is that what it's supposed to be? Anyways, welcome to the stream. And how can we help you on your cybersecurity journey? But yeah, NOP operation, no op. It's hex 90, yeah, for sure. So we need to figure out some other function that we can actually get a lot of output out of. Let's try sending, yeah, like I said, let's try sending 10,000 bytes. And we'll try some different functions. So we tried everything up until here. So there's only a few more functions to test. So there's gtir, htir, ltir, and kstan. So we'll try gtir. Oh, where are we? Here. Okay, let's fuzz this thing. Oh, okay. We managed to crash it with 10,000 bytes. I mean, I guess we need to incrementally go lower then. So this is gtir, 10,000 bytes. Let's try 1,000 bytes and increment by 1,000 bytes. Okay. We need to reset the server. Okay. Whoops. 1,000. So we crashed it with 1,000 bytes. We should probably make sure that this is not some super small thing either, because I'm pretty sure our malicious code is going to take up at least 900. Like 950? Hold on. Let me count. So we use something like if we create a payload using this program, we need 1500 bytes. So we need to find a function that's going to give us 1500 bytes worth of space. Okay, so we crashed the program with like 1,000 bytes, right? So gtir, we spent 1,000 bytes to crash the program. And let's go ahead and follow the ESP and the dump. so this is the same. We don't have any room to maneuver here. It just all zeroes out after. Thank you very much. Who sent that? AA Rune. Wow, another gifted sub to JMike360. Hello. Welcome. Thank you very much, AA Rune. Thank you. Jeez. Cyber Snail says there are a couple of two-stage payloads that can get down to 350 bytes first stage. Well, I mean, that means that we have to get 350 bytes worth. That's tough. That's tough. But first we need to locate where we can fit 350 bytes. But thank you very much, AA Rune. Let's give you a special redeem. How about Jurassic Park? There you go.
It's a unit system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so let's go back. Let's figure out if we can fit the malicious code in the beginning of the payload instead of after taking over the EIP. In which case we would do if we need at least 350. This is what we're going to do. We're going to send 500. And if 500 actually crashes the program, then we need to give up on this one. Because we wouldn't have enough room. But let's just run the thing. We got ads, but JMike isn't going to see them because they got gifted a membership, or sorry, a subscription. Thank you very much. Thank you very much for the gifted sub, Aaron. Thank you. Let's go ahead and put on some birds. How about this bird? That's a great bird. And let's see who just subscribed on YouTube. Four rule. Thank you very much for the sub on YouTube. Okay, let's. I'm gonna have a little water break. We'll be back in just a. Okay, let's put the bird away. We crashed it with 500 bytes, so this doesn't bode very well. I think we're going to need to abandon this function and then try another one, because I don't think we're going to have enough room. So let's try htur instead. Okay, and we're going to reset the server. Okay, let's try this. Okay, we're sending at least 1,000, 2,000. So if we have a lot of room before the crash, this is good. This is good. If we've got 2,500 bytes, then we can put our malicious code before the control of the EIP. So this was what is the name of this? This is the htur function. Okay, so it was 2,000 bytes. So we're going to start with 2,000 bytes. We're going to send. We need to figure out exactly how many we need to crash the program. I'm just going to send 100 at once. Okay, we're getting closer. Okay, so let's go ahead and try to crash the program, starting at 2,000 bytes. 2,000, 21. We crash it with 21, okay. So let's send 20 bytes this time. So instead of 100, we'll send 20. We're just trying to narrow in on exactly how many bytes we need to send to crash the program. We need to reset the server again. I'm going to be resetting the server so often. Let me check and see if the how much time I have left on the room. 43 minutes. We can add an hour. Okay. Okay. All right. Let's see. 2,000, 220, 240. Okay, so it crashes at 240. Eventually, we're going to get there eventually. Let's keep on narrowing down. So we start with 220, and we're going to send 4 bytes at a time. 4 bytes at a time. We're getting close. Okay, 224, 228, 32, 36. Does it crash exactly at 240? No, it crashes at 236. Huh. Okay, so we sent 236. Let's see how much we got into the EIP. So, let's see. The EIP... There's nothing in the EIP. Okay. We can probably figure this out pretty easily. Let's send 8 more bytes. Oh, sorry, hold on. 236 plus 8. So that would be 2044? No. So we're going to send 2044. We'll reset the server. Okay. So we sent 2044. That's going to crash the server. And then let's take a look at how many of those got into the EIP. None of those got into the EIP. There's no 41s in the EIP. This is not good. Let's send... Okay, let's... this is not a good sign. Let's send another. Let's send 100 more. No, we shouldn't send 100 more. Let's send 8 more than this. So let's see. 8 more than this is going to be 52. Okay, let's reset the server again. Okay, so we sent this payload. Hopefully we can see some A's in the EIP, because otherwise we're not in good shape. Okay, so the EIP now has a bunch of A's in there. So we just need to figure out exactly how many we need to send to fill up the EIP with these A's. Let's send 2 less. So we're going to go from 2052 to 2050. That crashes the program. We still have a bunch of A's in here. I need to send less. Okay, we'll send 2 less again. Yeah, we do have the framework, and we can use. I'm just trying to do this. I'm trying to do this manually, just just so I can get a feel for it. But I think there's something wrong with this function as well. But let's not get ahead of ourselves. Okay, so we sent 2048, and we're trying to find out if we start seeing less of the A's in the EIP. So we see one less. We see one less character in the EIP. That means if we send one more, we should fill it up. And if sending one more doesn't fill it up, then we've got a problem. Okay, let's narrow in. So we're going to send 250, 249 of these. Okay. So we sent 249. It should be completely filled. The EIP should completely be filled with A's. And it is. Okay, that's good. That's good. So we need to figure out if we can control the EIP with whatever we want. So this is what we're going to do. We're going to send. Wait, how large is the buffer? So the buffer is 1. Oh wait, no, this is no good. This is no good because the EIP is filled. It should be filled with 41s, but it's filled with these A's. This is not. We can't use this. Because the characters get transformed. So this is okay. Let me follow this. So there's going to be the ES, EB, ESP, follow and dump. And yeah, for some reason these characters get transformed into these hexadecimal AA characters. Which means we can't use this. Actually, I don't see any of the 41s. The hex 41 is what we're actually sending, but they're being transformed into these hex AA characters. So it means we can't use this. We can't use this function, so we need to move on. So that's no good. Okay, we have to abandon this one. Yeah, it's really weird. Alright, let's move on to the next function. There are not very many functions left to test. That was the hchur function. So the only functions we have left to test are lter and kstan. Okay. Alright. None of this stuff has worked. Okay. Let's do it. 500, 1,000. I think this might be a non-vulnerable function. We'll wait for a while to see, if it gets up to like 90,000 or something. If that's the case, then we're going to have to abandon this one as well. Let's see, what other... So we're testing lter right now. The only one after this is kstan. Yeah, I don't think this one's vulnerable. Okay. We'll wait for it to go beyond like 20,000. Then we'll test the last one. Okay, that's no good. Let's go ahead and switch over to the last one. So the last one is Kstan. I don't know if there's something I'm missing here. Okay, it looks like, wait, do we have a crash? Nope, not yet. It's over 9,000. Okay, you know what? we're gonna just so we're not spending like hours and hours on this, we're gonna switch up our topics, and we're gonna go over to another CTF game. So the CTF game we're gonna be taking a look at is Under the Wire. Under the Wire, I think it's called Sentry. But this is basically this is all about using PowerShell. Okay, so the goal of the level is to log into the game. Basically, this series of CTF games is all about using PowerShell commands, and this is something I've been interested in for a while because we don't talk very much about getting good at PowerShell. Although I guess we should, because you know it's a very commonly used scripting language, right? Let's see. So I don't know. This thing is I've been working on this thing for 3 weeks and I still haven't been able to break through. I'm really sad. Thanks for the resources. Signing off for the night. J Mike, hey, nice to see you, and thank you very much for chatting in the stream today. Let's give you one last hack the planet to send you off on.
Hack the planet! Hack the planet! Shut up and get it!
Hope you have a good night. Man, I really want to finish this box. Maybe, I don't know, maybe I should take a look at a write-up. Because although, yeah, I've been smashing my head against this thing for the last 3 weeks. Hey, 8-Bit Bandit has just subscribed with Twitch Prime. Thank you very much for subscribing, 8-Bit Bandit. And let's give you a fun video redeem. How about War Games? Here you go.
We're in.
Shall we play a game?
How about global thermonuclear war?
Welcome and thank you very much for the subscription with Twitch Prime, 8-Bit Bandits, 8-Bit Bandit X. Okay, yeah, I don't know. Maybe I should just bite the bullet and take a look at a write up. Let me see if I can find something. Let's see, the Hackers Labs, Pila, write up. Pila, the Hackers Labs. Okay, we've got oh, you know what? They've got write-ups on their page, I'm pretty sure. Yeah, they've got a write-up here. Hold on. Write-up video and write-up text. Let's see if we can take a look at one. I'm sorry, everybody. I really want to solve this thing. Okay, we got our write-up. Let's see if we were actually on the right track or not. So we discovered a service. We downloaded the vulnerable binary from a web page. After that, wait, am I looking at the right? Are we looking at the right thing? I don't know if we are. Hold on. No, this doesn't mention Pila at all. I think we're on the wrong page. Okay, let's try this one. Okay, this one is a PDF. Let's download it. Okay, so let's see. So it looks like they're doing the same kind of stuff we are. Zen says, for a working environment, what should I use while doing PicoCTF for research? Like VPN and virtual machine, and do you know any free VPNs? So when you're talking about PicoCTF, most of the PicoCTF challenge, okay, not most. A lot of the PicoCTF challenges can be solved by using their tool, so their built-in tool. And let me point it out. So PicoCTF. So when you log into PicoCTF and you go to the practice section, you scroll down, you're going to see this web shell button over here. So the web shell is actually a Linux virtual machine that you can use to solve PicoCTF challenges. So let me point out a challenge over here. Maybe we're looking at general skills, and we're looking at I don't know. Something like glitch cat. So this challenge over here, it says our printing service has started glitching. Additional details will be available after launching your instance. Here's the thing. Most of the time, if you're working inside the terminal to solve one of these challenges, you can just use the PicoCTF web shell. And the PicoCTF web shell is a fully functional virtual machine that usually has all the tools that you need to solve these challenges. So I think it is like Nmap. No, it doesn't have Nmap. Does it have? I mean, it has netcat. It has. Let's see. Does it have John the Ripper? No, there's no John the Ripper. It has XXD. It has binwalk. Most of the time, if you can solve the challenge by using like terminal commands, it has the terminal programs that you need to solve the challenges built in. But if you're talking about research in general, then I think you should use a virtual machine like a Kali Linux virtual machine. So if you don't know how to install like a virtual machine on your own host machine, you probably need a good amount of RAM, especially. So memory is very important when you're running virtual machines. I've got a little guide for installing Kali Linux and VirtualBox on your computer, especially if you're using a version of Windows like Windows 10 or Windows 11. This is the link for the video. But let's get back to cheating on this challenge over here that's been frustrating us for weeks. Okay, so it looks like they're using Immunity debugger just like we are. And they're talking about fuzzing, offset, payload. These are the exact steps that we use. And It says that the command we want to look at is trun. That's strange because we tested this one already. And I wonder what they're doing that's different from what we're doing. So fuzzing, they fuzz with a bunch of bytes, and I think they stop with 5900. Oh, what is this? They're sending it with some other characters. They're sending it with slash dot colon slash. Slash dot colon slash. I wonder what this does. And it says that it crashed with at 5900 bytes. Slash dot colon slash. Hold on. Let me test this out myself. Okay, let's go back. So here, let's reset the server. Okay. Slash dot colon slash. In why do we need to use these special characters? And where would you infer this? Hold on. Okay, let's netcat into the machine. Help. So valid commands are this. It doesn't imply that we need to use special characters. It just says stats and stat value. So we would do, what was it? trun slash dot colon slash and then a bunch of crap, right? Let's see if we can crash the program using a script. So it's trun and then slash dot colon slash space, or no, it's not space, and then whatever, and then the prefix, which is 5000. It said it crashed with 5900 bytes, right? Okay. It's running right now. We run the script. Whoops. We run the script over here. This is really frustrating. Because there's nothing to imply in the program here that we're supposed to use these characters. I don't know. Let me take a look. Let me take a look at the downloads directory. So we've got a copy of the original binary over here. If we run strings on Vuln server, there might be some help text or something, right? So let's so we'll run strings with maybe minimum 10. So these are all of the sample strings. Okay. Okay, Okay, you know what? We're just going to keep on going on. We're going to keep on going. And we're going to try to do the rest of the buffer overflow. But the fact that there was no clue. There's no way we could have gotten the knowledge that we were supposed to prepend the command with these special characters here. Anyways, I'm not going to look at the rest of the write-up. Let's just continue on from where we are right now. Okay, so I'm going to find out where exactly we control the EIP. So let's continue iterating on this. Okay. So 5900, we're going to start at 5800. And we're going to send 10 bytes at a time. Okay, 5800. 5800 already crashes it. Okay, so that means we need to lower it even more. So 5700. We got ads running on at Twitch, so we run them on YouTube, and then we play some birds. How about these birds? Okay, I'm just gonna have a little water break. We'll be back in a little bit. This is very, very cute. They just keep on picking up the peanuts, and they're trying to figure out which are the good peanuts and which are the bad peanuts. Alright, let's put the birds away, and we'll get back to the hacking. Okay, so 57. We'll do 57, and we'll try to figure out the exact offset. $57. Does it actually occur way before 57? Let's do 55. And we'll increase by 50 each time. It said in the write-up, it says like 59. It says 59. Oh, you know what? Maybe... 57, 59. 55. What do I have set it to right now? So I've got 55 right now. So it's probably going to occur sometime between 55 and 57. 100 bytes. Okay. Okay, let's run it. So 55 also crashes it. So what doesn't crash it? Let's start at like 3,000 or something. 3,000 and then add more. So 3,000 and add 1,000. Let's add 500 each time. Okay. Let's go back. 3,000. 3,000 crashes it. $3,000 crashes it. So this is Janny Hack. Hello, nice to see you here, Janny Hack. You know, it could be that the test machine and the actual machine that we're hacking against are going to have different memory locations, or I don't know. Let me try hacking against the other IP address where the actual machine is. So the actual machine is at address number 3. You're running a back test. Back test? I'm not too sure what you mean by back test. Let me know. Let me know what exactly you mean by back test, and I'll answer your question. Okay, the IP address is going to be this one. Okay, so we're now running it on 3,000 bytes crashes the server in this case. Zen says, I gotta head out. Thanks a lot for the advice. Hope you have a great night. Hope you have a great night, Zen. And yeah, great having you here. Let's give you one last NanCat to see you out. Okay, let's try 1,000 bytes. Because this is still really suspicious. Okay, so reset this thing, get it going again, and let me get the IP address for this. Okay, let's put in this IP address again. So 1,011. Okay, so this is good. This is good because we've got enough room to put in our payload before the EIP, we control the IP. So we just need to figure out exactly at what point the EIP gets taken over, and then we can start crafting our payload. So 2,000, and when we send 2,000, oh, there's no... it doesn't get taken over. The IP doesn't get taken over when we send 2,000. So we need to send slightly more. Okay, so let me start it. Let's send 2020. Okay, and let's send it. Okay, so if it worked, we should see some, yeah, we have some 41s in the EIP. So we just need to send less until we can figure out. Let's send 8 bytes less. Okay. So we send 2012. And that still overwrites it completely. Let's send 4 less now. Okay, send it over. 2008 bytes. It's still full. Okay, we'll send 4 less bytes again. So we're very, very close. Okay, send it. Yeah, it crashed. Okay. So it looks like we've got 141 in here. So we need to send 1, 2, 3. We need to send 3 more. So if we send 3 more, then we fill it up. That means we've got the exact offset. So 2007. Okay. Reset this thing. This is the scintillating excitement that you were expecting when we do hacking, yeah? Okay. Okay, that crashed. So we filled the thing up completely with 41s. So 41s is the A character, and we need to figure out if we can just fill this up with exactly what we want. Which means we're going to do one more adjustment. So we're going to subtract 4 from here, so 2003, and then we're going to add a bunch of 3 characters. We're going to send 4 3 characters. And if we see that, that the EIP is overwritten with 3s, so hex, the hex for the number 3 is 33, and if we see 33s all across the board, then we've successfully overtaken the EIP exactly. Okay, let's do that. Okay, send the payload. Okay, so the EIP is overwritten exactly with a bunch of 3s, 33, hex 33. So yeah, the next thing we need to do is we need to let's see. So according to the room over here, these are the steps. So the steps are: we do the fuzzing. We did the fuzzing already. We did the crash replication and controlling the EIP. We've done this. And we, over a couple of, like maybe last week, we looked for bad characters. And we found that there were no bad characters in this particular binary. So we don't need to worry about that. So we need to find a jump point. So let's see, with this thing running in the state, we need to run this Mona command to find a jump point. And then we need to generate a payload in the forbidden platform. Okay, so find a jump point. Anyways, this is what we're going to do. We're just going to grab this this other script over here that is all about sending a bunch of different information to the binary, and we're going to start writing this up. So let's see, we're going to call this overflow.py. We need to adjust it for our current environment. So this one is, oh gosh, was it? Just a second. So it's trun plus these special characters. It's still It's still very irritating that we need to include these special characters, and we have no way of knowing that we're supposed to include these, unless there was some sort of document that we could have found that would point us in this direction. Anyways, this is what we need to send. So the overflow is going to be A times the offset. The offset is 2003. And then the return is going to be the return. We need to find a return address. And then we need to set up a payload. Let's try setting up the payload first. So the payload that they recommend to us in the in this room here is this one. So we might as well try this one. Okay, so the payload, let's make it using the forbidden platform. Let's see, lhost, your IP in the L port. So this is going to be it. Hold on, gotta keep the music running. And I need to get my IP address. So my IP address is this one. This is our IP address on the TryHackMe network. Okay, and let's create the payload. Okay, so this is our code. So this is 1,506 bytes. Now, how do we incorporate this in the Python script? Copy the generated C code strings and integrate them into the script payload using the following notation. So payload is going to be whatever payload we've got there, but we need to wrap it up in these parentheses. Okay? Copy this stuff, go over to the script. Okay, so the payload is going to be paste all this stuff in. I think we can get rid of we can wrap this up in the parentheses. Okay, is this going to work? Mm-hmm. Okay, so let's see. What do they recommend in the room here? So prepend the no operations. So no operations, I guess. Can we put this? Okay. My big question is, can we actually put the payload after the EIP? Hold on. Let's go ahead and get rid of the we'll just comment this out first for now. Oh, wow. It looks like this abundance of... Okay, let's just get rid of this stuff right now. Okay, the payload is going to be... What are we going to supply as the payload? So let's just do C times, actually just do 33. 3 times 1,600, because this is what we're going to need to get the full payload in. So the return is going to be, I don't know, we're going to call these BBBB. Okay, after this, I'm going to save the modified buffer. I'm going to make sure that the server is ready to test again. Okay, so we sent the buffer. That should have crashed the program. This did crash the program, okay. Let's follow the crash in the ESP. Hold on. Are you on LinkedIn? Yeah, I am on LinkedIn, Samir's Tech Tips. You can send me, go ahead and send me a Twitch whisper, because I don't include my LinkedIn on in links in Twitch chat or YouTube chat. Send me a private message, and I can hook you up with that. So it looks like we filled everything up. For some reason, I can't. This thing crashed. It crashed. I can't access this thing right now. I can't do anything. I need to restart this. Hold on. Okay. Restart. Okay, so what are we trying to do? We're trying to follow the ESP in the dump. So we got 3, well, we got a lot of these 3s. And hopefully there's enough room for our shellcode here. It looks like so we could do some hexadecimal calculations to figure out how many of these 3s we've filled this with. So it looks like it's 1, 2, 3, 4. We got 8 per row. Let me go ahead and record this number. So this is 01A 01A7FDB0. So this is the this is one of the addresses, and we need to subtract the beginning of the 33s. Sick in the Mind, hello, sup? What is up, Sick in the Mind? We're doing this box again. We're doing this GD box again. We're getting closer. We managed to find a the function that is vulnerable. And we're just trying to figure out how to run our vulnerable code or our malicious code. So this is 0A. This is 01A7. 01A7F9E0. F9E0. So the function was the I had to cheat. I had to cheat to figure out what the function was. I took a look at a walkthrough. You know what really made me mad about the walkthrough is that when I took a look at it, they're not using the command the way you would normally expect it would go. They're actually, hold on, where's it? Where's this stupid thing? They run trun, this function that you get from the binary, but they also append a bunch of special characters, and that's the way you get this thing to crash. So slash dot colon slash. If you know what this actually means, yeah, that was my reaction as well. I did a big WTF. I have no idea. No, I have no idea either. But apparently, you're supposed to find out some way that this is... it doesn't make any sense. No, it doesn't make any sense. You don't think it's required. If you don't include these special characters, the program doesn't crash. And this, if you don't include the special characters, the function's not vulnerable. I've tried it without it, and I've got up until into the hundreds of thousands of bytes sent, and it still didn't crash. It's really dumb. It's very dumb. Hold on, let me play some new music. Did they reverse it with IDARs? I don't know what they did. I don't know what they did. Anyways, let's play some moody music. There's got to be some sort. Yeah, there's probably some sort of explanation. I'll probably take a closer look at the at some other write-ups after I'm finished with this. Anyways, okay. So I'm just trying to figure out if I can. If they didn't document the Y in that report, they used someone else's write-up too and skip that part. Maybe. Okay, we're just doing a little bit of binary math. Sorry, not binary math, hexadecimal math. So let me grab my hexadecimal calculator to figure out, let's see, hexadecimal calculator. Okay, so we need to calculate hexadecimal calculation, add, subtract, multiply, or divide. So we're going to this number minus this other number. Okay, so this hex minus this hex. Wait. Oh, that's not supposed to be it. This is supposed to be it. Calculate this. Okay, so the decimal value is 976. So this still isn't enough room. This still isn't enough room for my shellcode. Because the shellcode that I've got right now is 1,506 bytes. I'm going to need to confirm this. Although I do... Somebody in chat suggested that we could make smaller shellcode payloads. So attempting to encode the payload with one iteration of... Well, actually, let's not encode this. Maybe if we don't encode this, it's not going to be as large, right? Wait. Oh, no, I'm reading the wrong thing. It says the payload size is actually 531. So yeah, we've got plenty of room. We've got plenty of room to include our payload then. Good. Okay. So we just need to find a jump point. Okay. Okay, so over here, overflow.py. Our payload is going to be this. And the return. So we need to figure out what the jump point, what the jump address is going to be. So the jump address is going to be what we got. Okay, so with this thing running in either running or in a crash state, run the mona command, and we're going to figure out which address we can jump to, which jumps to the ESP. This command finds all the jump to the ESP or equivalent instructions with addresses that don't contain any of the bad characters. So we want to jump to ESP, and then it'll execute whatever is in immediately after the ESP. So let's go and do that. Hold on. Someone on Stack Overflow mentioned that this syntax is needed for the truncated command due to an if condition in the code. And they reference the source code on GitHub for Vuln server. Not sure if that helps, just got here. Truncated command due to the if condition in the code. How would you discover that naturally? That's what I want to know. But thank you very much for the information, Samir's Tech Tips. Okay, so let's grab this. And we should see this in the log window. Okay, so we got 9 pointers, and we've got some... Let's grab the first one. I can't read any of this. This is all very, very small text. Can I copy? Copy to clipboard. The address. Okay, so the return is going to be this address, but the address has to be put in reverse order. So the reverse order is going to be hex, 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 hex. So hex AF, hex 11, hex 50, and then hex 62. Okay. All right. So after that, we need to put in some padding, I guess. Well, we can put it in just for just over here. So maybe some no operations, 16 of them. Sure, why not? Okay, so after that, it seems like this is all we need. Okay, let's save this. What we want to do is we want to get a reverse shell connection. So we're going to run netcat and get our reverse shell listener. Then we'll reset the server. there's an if if condition in the code. There's a source code for on GitHub for vuln server. So vuln server, there's a GitHub project for it? Jeez. Are we supposed to know about that? Hold on. Vuln server, GitHub. Vulnerable server. Oh, okay. So what we're supposed to do is we're supposed to research this. Oh, interesting. You know, that kind of makes sense. We would probably research. Huh. I feel less bad. I feel less bad if this is what is actually happening here. So we actually have source code. Everybody, this is what I'm looking at over here. Just in case you're wondering. Okay. Okay, so this is ready for testing. Okay, if that worked, I should get a connection on my... Oh, okay, it works. Yeah, sure. Okay. You know what? You know what that means? That means we're very close to getting in. All we need to do is adjust our payload. Where's our payload? And we need to... The only thing we need to do is we need to change out the host, the listening host. It's got to be this address over here, because I'm gonna be so happy to be finished with this machine. I'm gonna be so happy to be finished with this machine. Okay, so this is our IP address here. Let's go ahead and craft the payload. There. Okay, so we're just gonna grab all this. Okay, replace the payload. Put this between some brackets. Okay, and then for our, let's call this our shell access tab. So shell access, let's make it a funky color. Let's make it yellow. And let's do RL wrap netcat 443. Okay, the only thing we need to do now is we need to adjust our hacking script to include the right IP address. And then Bob is your uncle. Whoops. Okay, let's do it. It worked. There's no privilege escalation on this box. There's no privilege escalation on this box because the service is being run by NT Authority System. Wow. Wow. Just wow. All right, well, let's call in Scary Hacker Voice Man so we can talk about all the stuff that we learned in for working on this box for the last 3 weeks. Hold on.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a server, and we just broke into this one. Well, Mr. Pila Administrator, it looks like you left a binary service running on your network, which has a buffer overflow vulnerability in it. That was a big mistake. We took a lot of time to research what the heck was going on with this vulnerable server, but eventually we got buffer overflow access, and then we got in. Maybe you knew about this problem with your software, or maybe you decided to accept the risk. Well, you accepted the risk. And now we're in.
Okay, well, it feels good to be able to finish this box after so many weeks banging our head against it. Let's make sure that that we actually have NT-authority system access. We should be able to enter. Well, okay, we're in the administrator's desktop directory. There's a root.txt flag here, so I guess that's all the proof we need. So we're not going to read the root.txt flag because we're trying to be polite to the organizers at thehackerslabs.com. So we're just going to type root.txt and redirect it into a file called iread root.txt like this. So if we manage to create it, that proves that we got access to root.txt and finished the box. Okay, so jeez. I'm gonna have a lot of time. I'm gonna have a lot of fun doing my reading all the write-ups for this room to figure out how exactly we should have been able to get here organically. I guess it would involve taking a look at the code over here. So let's see. So essential function vulnserver.c. So yeah, we're talking about okay, let's go ahead and use our knowledge of C and try to understand what the heck is going on here. So the trun function was the vulnerable function that we had to target, and let's find it in the code. Okay, so where was the... okay, so the trun function is allocated 3,000 bytes. And I guess Samir's Tech Tips told us about an if statement where you had to send some weird special characters. Was this? gdog, kstat, gter, hter, lter. String compare. I still don't get it. I still don't get it. I still don't get it. It doesn't say anything about the if statement over here. But you know, it's okay. I'll take a look at the the write-ups, like I said. Let's go ahead and do something a little bit less rage-inducing for our last little bit of the stream. So let's go ahead and go over to Under the Wire Sentry over here, and let's practice doing some PowerShell. So if you haven't taken a look at this before, this is a war game, a CTF game that is very similar to, in spirit, to the Bandit CTF game over at overthewire.org, except that this is looking at PowerShell instead. So I've always wanted to learn about PowerShell because it helps me write Windows scripts better, and let's go ahead and do that. So let's see. After obtaining credentials, obtain the credentials via the Start Here channel on the Slack. Once on the channel, scroll to the top to see the credentials. I think we could probably just get the credentials from a write-up. It's probably less... it's probably less obtrusive than trying to find it on a Slack channel. So let me go ahead and see. Under the Wire, Sentry, password. And this is level 0, right? Sentry level 0. Oh, the AI knows it. Are you sure this is the password AI overview? Anyways, we'll give it a try. Okay, so let's see. What is the address? The address is going to be sentry.underthewire.tech on port 22. Okay, so the regular SSH port. Let's get out of here. SSH Sentry 0 at sentry.underthewire.tech. Okay. What's the password? Is it this? Looks like it was not it. Hold on. Under the wire, the password will be lowercase, no matter how it appears on the screen. Okay, I just need the password for the very first level. It looks like we're gonna have to. It looks like we're gonna have to access the Slack channel. The link is no longer active. Huh. Wait, I wonder if they have a Discord channel now instead. Let me see if I can find it. So Under the Wire Discord. Hold on. Man, I just want the password for the first level. Okay, so 0 to 1. Okay, I guess, okay, let's go to the official site. So the official site is here, and it says, obtain the initial credentials via the Start Here channel on the Slack. Here's the link. Please enter your email to get the invite. Where's my Slack? Is it still running? Okay, hold on. Let me put in an email. Get the invite. Already in team. Okay, so I'm already in the Slack. I guess what we need to do is open up Slack. But I don't see it in my list of workspaces. Sign in to find workspaces. It says I'm already in. I'm not super good at using Slack. Let's see if I can sign into another workspace. And okay, so I do have Under the Wire. And what are we supposed to do? So we're supposed to go to the Start Here channel in the Slack. Start here. And oh, you know, this is weird. So it's not Sentry 0, it's Sentry 1. Sentry 1 is the first one. I should have been able to guess that. Silly me. Okay, let's do this again. So Sentry 1. And the password is also going to be Sentry 1. Okay, we're signed in. So we're doing PowerShell in, and we're logged in. So what is the goal? So the goal of the level is what? So the password for Sentry 2 is the build version of the instance of PowerShell installed in the system. So the build version. Okay, so be sure to look for the build version and not the PowerShell version. Okay, so build version, well, I mean, I guess we would just Google all this stuff. So PowerShell build version. So PowerShell, enter the command, type PS version table. PS version table. Build version of the instance of PowerShell. So exclamation point, sorry, $, PS version table. PS version, PS edition. PS. So let's see. It looks like it could be this. Yeah. So this is 1, 1, and then 5 digits. Does it match? No, this doesn't match. The format is as follows. It says build version. Look at the build version, not the PowerShell version. So it looks like the AI has led me astray. Determine installed PowerShell version. So this is not... How to find the build version of PowerShell. Within PowerShell itself, PS version table. What is the difference? Okay, this is locate the build version. The output will display various PowerShell properties. The build version field shows the build number. Okay, so build version is going to be this. Okay. So 10 something something. So 2 digits, 1 digit, 5 digit. So this is probably the answer. Two digit, 1 digit, 5 digit. Yeah, this is the answer. Okay. So I guess I could... Well, we'll test. So Sentry 2, try to log in. Whoops. Gotta... Okay, is this the password? It is the password. Great. Okay, so what command did we use? We used the PS version. What was that? PS version table. This was the command we used. Let me just do a quick write-up over on my GitHub over here. So HackerFrogs write-ups. So everybody, let me know what kind of content you want to see on the stream, because if you want to see more content on XYZ topic, I'm very happy to give the people who are watching what they want, because I'm looking to expand the topics that I do on the stream. Okay, let's add a new file. This one's going to be called Under the Wire. And this is going to be the Sentry game. So let's see. This is level 1.md. Okay, let's start editing this file. So username, password, method of solve. Actually, okay, so it's going to be username, password, objective, method of solve. So the username is going to be Sentry1, password is also Sentry1. The objective in this case is, I'll just copy it directly from the website here. Okay, let's paste this in. Okay, and then maybe like this. Yeah, all right. Okay, so let's see, the method of solve. So the following command will give you a number of variables for the PowerShell version and build. And the command is this one over here. So PS version table. Not that this is super relevant to your day-to-day operations using PowerShell, but sure, why not? Okay, done. Oh, the other thing that I'm interested in doing is doing more AI stuff, because I was trying to get some agentic AI stuff working on working with my virtual machines. So that's basically getting the AI to run computer commands. So what was I looking at? I was looking at, what was it? Claude AI? Claude AI computer use. So this is basically getting, yeah, they can now interact with computers through a new computer use feature, allowing it to move the mouse, click buttons, and type on the screen based on user commands. Check out Warp. Warp? What do you mean? What do you mean by warp? But yeah, we've got to introducing computer use, a new Claude 3.5 Sonnet feature. So this actually came out like last year. The intelligent terminal, Warp, the intelligent terminal. Maybe I will. Maybe I will check that out. But this is what. Let me get into this article, and I'll leave the link. Okay, so Warp, the intelligent terminal. Okay, so Warp is an intelligent terminal with AI and your devs. Okay. So warp.dev. Let's take a look. Hold on. Let's make this bigger. Okay, become a command line power user on day one. Warp combines AI and your dev team's knowledge in one fast, intuitive terminal. Debian, Ubuntu, Red Hat, etc., etc. What does this do? Warp keeps me in flow. I'm not sure this is exactly what I'm looking for. So this is basically an AI assistant, right? That helps you code stuff. Why is this? Oh, there's agent mode. Interesting. Hold on. Let's see. AI tools, warp drive. All features. Let's take a look at all the features on this website. Your terminal reimagined, appearance and customization, modern text editing, Warp AI, Warp drive, collaborations, routines, usability. So let's take a look at, let's search for agent. Prompt suggestions. Get contextual AI-powered suggestions that activate agent mode. So I don't know if this is exactly agentic AI or not. If you can get the AI to do stuff for you, that would be agentic AI. And this is something that you can find on YouTube. There are examples of Claude AI is probably the most famous example. Let's see if I can find a video or two. Agentic AI Claude. So yeah, Claude has taken control of my computer. Sure. How to install and use Claude's new AI agent. This stuff is not super recent. That's kind of strange. I guess people kind of... Tips for building AI agents. This is from 2 months ago. So this is from Anthropic, so it kind of makes sense because they're the people who make the AI that does this stuff. So what I want to do is I want to do more experiment with agentic AI. The problem is that it costs money. It costs money to use. But I want to do some experiments to see if it can solve simple CTF exercises, because that would be pretty neat if it could. But I'm going to be exploring more of that in the future, in the next coming weeks. Hopefully we can get something going, because it's something that would get me a lot of attention on YouTube, probably. If I do some videos where the AI is able to solve CTF exercises and do cybersecurity stuff. But yeah, let's make this nice and pretty, and then we'll move on to the next level. Okay, let's save this out and move on to the next level. Oh, I don't think I saved the output from the last level, which is kind of sad. Anyways, let's go back into the previous level. Okay, so the command was ps version table. And this was the password for the next level. Let me record this. Okay, the new level is going to be level 02. Okay, so username Sentry 2, password this thing, objective. Let's copy the objective directly from the website. Okay, so the password for Sentry 3 is the name of the built-in commandlet that performs the wget-like function within PowerShell, plus the name of the file on the desktop. Okay, let's, that sounds interesting. Let's go back. Samir's Tech Tip says, I used it on Ubuntu to automate utility scripts, mainly for lightweight task execution and file handling. For any system-level changes, it required authentication, either via sudo or user verification. So you got the AI to run tasks for you? Is that what you're trying to say? You used it to run utility scripts. Is that what you're trying to say? Okay, so the last thing is method of solve. Built-in commandlet that performs the wget-like function in PowerShell. What is the built-in commandlet that performs wget? Wget commandlet PowerShell. We could probably just search for that. Wget commandlet PowerShell. Download. Native alternative to wget in Windows PowerShell. Downloading a file with PowerShell. Invoke web request. It's probably invoke web request, right? That's my guess. I'm kind of sad that we're not using actual PowerShell commands to get the passwords. Similar 6 it ran tasks for me current and can cron out tasks too. When it comes to agentic AIs, there may be some models and frameworks available through OpenAI. There's probably, when it becomes available on OpenAI, it's going to become a lot more popular because most people only know about OpenAI and about ChatGPT. Have to run for now. Nice to see you. Great channel. Thank you. Thank you very much, Samir's Tech Tips. Why don't we give you a Hack the Planet, and hope to see you again.
Hack the planet! Hack the planet! Shut up and get it!
Okay, so let's see. wget commandlet PowerShell download. It's probably going to be invoke web request, right? So it would be invoke web request and then the name of the file. So wait, did they say where the file was going to be? Plus the name of the file on the desktop. Is there a file on the desktop? Oh, no. I need to log in as Sentry 2 before I do this. So the password for Sentry 2 is... Gotta get it again. This thing. Okay, paste in the password. This is 443. So invoke web request 443, like this. Is this the password? Let's check. So we can check by trying to log in to Sentry 3. Maybe that was not it. Okay, so let's reconsider. wget commandlet PowerShell, and are we looking for an alias? Okay, so in earlier versions of PowerShell, wget was an alias for the invoke web request commandlet. Invoke web requests. Hold on. What is the format? Get web, and then just basically concatenate the thing, right? The password would be lowercase, no matter how it appears on the screen. Okay, so we need to convert everything to lowercase. So in that case, the password is actually going to be invoke web request 443, like this. Let's test this theory out. Okay. And that was it. Okay. I think we're actually getting into some actual PowerShell now. But let's go ahead and do our write-up. So let's commit this first. We're gonna paste in. We're going to get the paste in the password for level 3 first. So this is going to be level 3. So username, password, objective, method of solve. So level 3, the username is Sentry 3, password is going to be this, objective, who knows. Let's commit these changes first. Okay, let's finish the write-up. So the method of solve. Okay, through research, we find that the wget command is actually an alias for the invoke web request. I guess we should make this capitalized. So invoke web invoke web request commandlet. And the name of the file on the desktop is 443. Which we can obtain by using the following command. And the command is dir. Very fancy. Okay, so that means that the password is... Oh, okay. Considering that the password is always lowercase, no matter what. That means the password is invoke web request 443. Just like this. Okay, let's save this out and let's move on to the next level. I think we can. Oh wow, it's 8:30 already. We'll solve one more level and then we'll get going. But let's solve one more level and let's see if we actually need to do some serious PowerShell stuff for the next level. Okay, so that's the password. Let's log in. Oh, we're logged in already, jeez. Okay, so count me. What is the goal for this level? So this is Sentry 3 to 4. The password for Sentry 4 is the number of files on the desktop. Okay, so we can actually run some real PowerShell in this level. Let me go ahead and start editing this. Objective, method of solve. So how do we count the number of files? How do we count the number of files? PowerShell count files in folder. Sure. Count items in a folder with PowerShell. Trying to write a simple PowerShell script to give me the total number of items, both files and folders, in a given folder. Okay, let's Stack Overflow. This is some old school stuff right here. So let's see. The answer is write host measure count. So directory something something measure count. Write host get child item. Oh man, this is some real syntax, huh? All right, let's try this. So if we go over to our terminal, so this is, I guess what we really need to find out first is the name of the directory here. So does pwd work? Yeah, it does work. Okay. So I guess we're going to insert this for the file path. And the answer is 123. I don't think we need to end this with the semicolon. Yeah, it still works if you don't use a semicolon. Okay, so this is the key command over here. Okay, the following command will output the number of files in the current directory. And I guess we need to specify that directory. The current directory is this. Copy that thing. Okay, so the answer is 123. And is that the password for the next level? That it seems kind of weird if it is, but I guess all the passwords have been a bit unconventional. Let me try using that as the password. Okay, 123. Get out of here. Huh, that was the password. Okay. Let's go ahead and go back then. And we'll create, well, we'll just record this this password. David Motionless. Hello, nice to see you here, David Motionless. Welcome to the stream. You're now, welcome. How about we give you a nyan cat? Here you go. So we're just doing some CTF games over here. This is something I've been wanting to do for a while. It's the Under the Wire Sentry game. It's this is basically a CTF game where you have to use PowerShell commands to solve the levels. And let's see, username, password, objective, and method of solve. So this one is Sentry 4. Password is this, strangely enough. Okay, let's go ahead and save this out. And we're going to find somebody that we can raid into, because we've been online for way too long. Let's see if we can find somebody to raid on infosecstreams.com. So this is a great website for learning about all sorts of streamers who do cybersecurity content. But it looks like I'm the only person who's on from the channel. Let me check my Twitch to see if I can find somebody we can raid. Okay, it looks like we got Quantum Apprentice online right now with 13 viewers. Let's go ahead and raid into them. Bro, gotta eat something. Yeah, I gotta get some rest. It's Friday and everything. But we're gonna raid into Quantum Apprentice. They're currently doing software and game development. Let's check out their channel real quick, just to make sure they're doing something that we like. So Quantum Apprentice, here we go. David Motionless says, I enrolled into TryHackMe about a month ago, still just doing the intro courses. So David Motionless, well, before we go, we can give you some... Are you trying to get into cybersecurity? And if so, what kind of job are you looking for? Let us know, and then we'll give you some advice before you end the stream. How about that? Okay, we got ads. Of course, we have ads. You say you enrolled into TryHackMe about a month ago. What kind of background are you coming from? Are you familiar with tech stuff? Or are you trying to get into cybersecurity without any previous knowledge about tech? There's nothing wrong with trying to get into cybersecurity without a background in tech. It's just that you have to catch up with the knowledge while you're learning about cybersecurity is all. But it looks like we're not really doing anything tech related here, unfortunately. Let's raid into the science stream instead. Let's see. Science streams. This is a regular channel that we raid, and they're usually talking about science stuff. Yeah, okay. This is more like it. We're talking about fruit flies and stuff. Awesome. Okay, so yeah, David Motionless. I can also recommend some exercises over here. So I run a YouTube channel. We talk about cybersecurity stuff. And let's see. Okay, David Motionless says, I study mechanical engineering officially, but I know the basics of computer stuff because I'm chronically online and was in high school for electrical stuff and some PC and networking basic. Lots of info online that I won't bother with you now. Okay, that's not a problem. So TryHackMe's a pretty good place to start. I would say solving some exercises over at PicoCTF is also a good way to get started, because PicoCTF is a fun gamified version of getting into cybersecurity topics. And I've got a little playlist of challenges from PicoCTF. You're probably going to find that most of the first dozen or so exercises might be a little bit too simple for you, but that's okay. Just keep on working through the playlist. Eventually you'll get into fun stuff like web app security testing and maybe some cryptography or some digital forensics. And go ahead and check out the playlist over here. But welcome to the stream, and yeah, I'm here to help people get into cybersecurity. Another thing that's really good for getting into the cybersecurity scene is to locate your local cybersecurity meetup. So you can just type in the word meetup, and if you live in a sufficiently large city, you should be able to find a group of cybersecurity professionals or students who get together and meet on a regular basis. So, for example, I live around Vancouver, and let's see, Meetup Vancouver Cybersecurity. There are a number of different ones in Vancouver, for instance, such as DEF CON 604 and OWASP. There's usually an OWASP chapter in each big city. OWASP is the organization that talks about web app security. Oh, Serbia, okay. Belgrade. So maybe we could, let's see, Belgrade, cyber security. We can try meetup. Let's see, cybersecurity groups. Belgrade Meetup Group DC 381, cybersecurity groups. Hack the Box Meetup Belgrade. Interesting. Yeah, DC 381. DC 381. Okay, so let me 381 cybersecurity. Okay, so it looks like there's one here. I don't know if they meet up on a regular basis. Okay, let's take a look at this. There's 44 people in this group, and this, I can't read this. Let's see, no upcoming events. You probably want to contact a group that has regular events happening. I guess you could also look for, an OWASP group as well, so maybe Belgrade OWASP. But the site is cool. There's a few groups. Okay, it looks like there should be maybe there's a chapter in Belgrade. One says there's a meetup today. Well, if so, then you might want to go down there and take a look. Yeah. But anyways, we're gonna rate. Well, welcome to the HackerFrogs station, David Motionless. I hope I can see you next time. We're gonna take the weekend off, and we're gonna be back on Monday. So hope to see you then. Let's go ahead and set up the raid for the next channel. So raid science streams. I think that's how you spell it. Thank you very much for following on Twitch. Thank you. Matthew Welty, hello. I'm happy to be back. Hi, Matthew Welty. We're just going to be we're ending pretty soon, but welcome back. We're going to be back on Monday, and I hope to see you there. We can do more digital forensic stuff and more Linux hacking. But yeah, so we're going to go to the science streams. If you get there, please give this raid message over here. Hip hop hack, OS frog, hip hop hack, OS frog. Just like this. And that would make me very, very happy. Thank you. And we'll see you on Monday. Have a great weekend, and we will see you next time.
Hide the planet! Hide the planet!
Shut up and get in.